advice ko na yan hanggang sa matapos ang review 2. Okay? So pagdating ng review 2, doon yung time na magkakahiwalay kayo. Okay? So bali, ang multi-vector will concentrate to the BSEE, and then review innovation will concentrate to the BSCE, and Excel will concentrate to the BSECE. Professional subject na yung ano. And I repeat, yung review na ito hindi masyadong malalim. In-house review, hindi masyadong malalim ito. Mas malalim yung discussion sa actual review. Okay? Mas maraming mahihirap na problem, yung talaga, yung ipapa-exam sa'yo yung mga lumalabas na sa board exam. So ito class, parang nire-recall lang yung mga nakaraan, yung mga napag-aralan mo nung first year, second year, and so on. Kasi malaki yung probability or tendency na nakalimutan mo na. Kumbaga, i-refresh mo lang para hindi ka mahirapan. Yung ang purpose nito. Yung purpose ng review, by the way, ang unang pangalan nito is Review 1. Ngayon, Course Audit. Kasi yun ang nakapangalan doon sa CMO ng mga engineering. CE, ECE, and EE. Nakalagay doon, Course Audit. So, pero in reality, review din yun. Okay? So, hindi ito gawa ng St. Louis na curriculum. Gawa ito ng mga technical panel. Gawa ito ng CHED, approved by CHED. Okay? At merong grades ito. At ang magbibigay ng grades, yung review coordinator. Normally, nung panahon ni Sir Ronald, din ang review coordinator. Now, kung din pa rin ang review coordinator, ako ang magbibigay ng grades. Now, what are the basis in giving grades? There will be the whole review, course audit 1. Tatlo ang magiging major quiz nyo dyan. Isa ibibigay ng multi-vector, isa ibibigay ng Excel, at isa ibibigay ng RI. Averaging yon. Tapos, magkakaroon kayo ng final exam. Okay? At ako, the review coordinator, kung ako magiging review coordinator, ang magbibigay ng grades. Of course, kasama na rin yan yung attendance nyo. Bali, 6 meetings yan. Session 1 and Session 2 by the multi-vector to be checked by our secretary. And Session 3 and Session 4 will be conducted by Excel. Will be on November 14 and 15. That is Sunday and Monday. Don't worry, you will be excused from your classes. Sunday, Monday naman yon. And then the next is yung Session 5 and 6. Attendance pa rin yan sa review innovation naman yan. Okay? So, ibibigay ko na yung floor kay Engineer Orgeles at sana makisama kayo. Okay? Mr. Usal, yung wala ka pang code na nakalagay. Sana nakikinig ka. Justin Bautista, saka yung tunay na pangalan mo, kinalagay dito, Clyde, nakalagay.
Yes, sir. Nabanggit kanina ni Madam, no? OSH practitioner. Ako po ay OSH practitioner in construction.
Hello po. Sino po sila? Molina, BSc. Ano yung tinatanong mo? Mr. Molina. Sige, bago tayo mag-start, Polka. Hello, Polka.
Sir?
May I request everyone na paki-on yung cam ninyo? Tapos, screenshot mo, Polka, yung 7 pages. Nakikita mo yung 7 pages? Paki-on yung cam. Everybody. Please, everybody. Mabait si Sir Clyde. Sino tong Clyde? Siguro natutulog pa ito. Clyde? Paki-on po yung camera natin. Then Paul ka. Sige, screenshot mo na.
Actually din, I'm using my phone right now kasi yung laptop ko medyo nagloloko na
Sige,
naman
ako na lang.
po.
Ako na lang. Wait lang ah. Okay. Last word ko ito. Pwede kayong magtanong kay Raymond, kay Engineer Urgeles sa discussion nyo ngayon. Okay? Pero kung ang tanong nyo about yung review, course audit 1, pwede nyo akong itanong. Okay? Pwedeng i-address yung tanong sa GC natin. Okay? So, pero kung about your topic for today, ang tanong, kay Sir Raymond nyo dapat itanong yan. Okay? So, Sir Raymond, you may have now the floor.
Sige, sir. Okay, so again, good morning. So I am Engineer Urgelius, no? So isa ako sa mga reviewer, so yung mga nagtuturo sa Multivector, no? Sa Review and Training Center. Okay? So yung focus namin is BSEE, diba? So pero since mathematics naman yung subject natin, so then applicable naman to sa lahat ng courses, no? Okay? So open ko lang yung lecture natin ngayon. No? So, again, start tayo sa differential calculus. No? Okay. Okay. So, yan. So, again, start tayo sa diff-calc, no? Sa differential calculus. Okay. So, regarding sa board exam natin, no? Okay. So, actually, ngayon, madalas na lumalabas sa board examination ngayon sa pagdating sa differential calculus is more on applications, no? Okay? So, kaya yan din yung isa sa mga focus natin sa pagdating sa discussions natin sa review, no? Okay? So, again, yan yung gagawin natin ngayon. So, yun yung i-discuss natin. Okay? So, kasi dito sa multivector, so yung focus talaga namin is yung mga lumalabas sa board exam. No? So, nung nakaraang board exam sa amin, so hindi ko alam dun sa ibang courses, no? So, pero sa electrical engineering, so yung maraming lumabas daw sa mathematics is more on basic subjects lang. No? So, sa differential calculus, okay, so if I'm not mistaken, diba? So, ang lumabas na karamihan is limits. No? Okay? So pero yung limits actually yung isa sa mga pinakamadaling subject, no, sa pagdating sa differential calculus kasi nga meron naman tayong calculator, no. So yun yung ituturo natin, no. So again, ituturo ko sa inyo yung basic concepts which is usually yung focus ng review namin, and sisingitan ko kayo ng konting calculator methods, diba? So if applicable siya dun sa problem, no. Okay? So pero again, yung magiging focus natin is more on basic concepts, diba? So rather than the calculator methods. Kasi yung calculator method, kaya nyo yung gawin, no? So basta alam nyo yung basic concept. Okay? So, yeah. Okay? So yan. So during lecture natin, if ever meron kayong question, no? So try nyo na lang muna mag-raise ng hand, no? So makikita ko naman yung pag nag-raise kayo ng hand. So marunong naman kayo mag-raise ng hand dito sa Zoom, no? Okay, so then tatawagin ko na lang kayo so if ever may question kayo or pwede nyo rin akong i-chat, may private chat naman dito sa Zoom, no? Okay, so para kung ayaw nyo magpa-identify, di ba? So then pwede ko namang i-discuss sa klase yung question nyo. So I guess if you have questions, so ganun na lang, no? So para hindi tayo sabay-sabay magsalita, no? So para meron tayong order. So ganoon din kasi yung ginagawa namin sa multi-vector, no? And also mind your microphones, no? Okay, nakabayan? Kasi madalas talagang nangyayari yung background noise, diba? Especially kung aksidente nyo nabuksan yung microphone, diba? Especially kung recorded, kung i-record nyo yung lecture, diba? So kasi magkakaroon ng problem sa audio, diba? So if bigla-bigla lang nagbubukas yung mga microphones natin, no? So kung gusto niyo magsalita, so kung may question kayo, so then raise your hand or message me first, okay? So or pwede rin naman na i-chat niyo na lang sa akin yung question, no? Diba? So para i-discuss ko na lang sa inyo, no? Okay? So again, we are Multi-Vector Review and Training Center. So focus kami sa Registered Electrical Engineer. So last board exam ng September. So even though kalagitnaan ng pandemic, no? So tuloy-tuloy lang yung ginawa namin review. Okay? So para sa electrical engineer, no? So dire-diretso lang yung review nila. So recorded yung lectures namin. So kaya kahit na tapos na yung review session nila, so they can still watch, diba? So tapos meron kaming extension, diba? So na promo. Okay? Kumbaga nag-a-add lang sila ng 500 so para matuloy-tuloy lang nila yung review. Okay? So and medyo mataas naman yung passing rate namin, 'di ba? So umabot naman ng 88%, 88%, no? So again, so para sa registered electrical engineer, no? So tapos apat sa amin yung nag-top notcher. So top 3, top 7, top 8 saka top 8, no? Okay? So ayan. So and for now, so online din yung review namin. So although may balita kasi ako na mag-start ata ang chat ng face-to-face by January, no? So titignan namin kung makakasabay kami doon, no? Okay? So if you have questions so regarding dun sa multi-vector, especially yung mga electrical engineering students, so feel free to message me on Facebook, no? Okay? So nandun naman yung search nyo lang Raymond Orgelius, no? Okay? So, or message kayo dun sa page namin. So, Multi-Vector Review and Training Center sa Facebook, no? Okay? So then, so start tayo ng review, diba? Okay, so again, so we will start with differential calculus, no? Okay? By the way, sir, kayo na ba yung magre-record? Or sino magre-record ng video, ng lecture?
I think naka-record na to eh.
Hindi,
Apple ka?
Sir.
Naka-record na ba?
Ano sir, inaayos ko pa lang yung laptop sir. 5 minutes sir.
Wait lang, ako na lang siguro. Try kung pwede sa akin, ha?
Pwede sir, ginawa po kitang co-host sir.
Sige.
Recording in progress.
Okay na. Okay? So again, so let's start. No? So again, so we will have differential calculus. No? Okay? Okay? So sa differential calculus, diba? So syempre yung una nating part dito is definition muna siguro tayo, no? Okay, so ng derivative, diba? So what do you mean by derivative? Kasi yun yung isa sa mga important na concept na kailangan nyo malaman sa differential calculus para malaman nyo kung ano-ano yung mga pwede nating gawing application, diba? So for differential calculus, okay? So as we all know, differential calculus is mostly used, diba? So in calculation of the slope of tangent lines, diba? So for a given curve, and dahil doon, diba? So meron tayong mga pwedeng gawin na different applications of problem, diba? So pero again, so let's start with derivatives, okay? So siguro naman, so may idea naman kayo sa mga derivatives of common functions. So dun sa sinend kong handouts, diba? So kung meron na kayong copy nun, okay? So meron dong list, diba? So ng common functions, okay? So for the derivatives, diba? So mas maganda kung memoryado nyo sila, okay? Okay? So kasi kung hindi nyo memoryado yung derivative, mahihirapan talaga kayo sa problem, no? Okay? So huwag kayong umasa dun sa derivative ng calculator. Okay? So kasi hindi naman all the time diba? So is meron sa ating given na point kung saan sinasolve yung derivative. So it's still better, diba? So kung marunong kayo mag-derivative ng common functions, diba? So yun lang naman yung kailangan yung gawin. So mag-memorya kayo ng mga derivative ng common functions, tapos gamitan nyo lang ng mga rules, diba? So for complicated functions, diba? So pag pinagsama-sama na natin yung mga functions natin, so then gagamitin nyo lang yung mga rules natin, diba? So ano ba yung mga rules natin sa calculus? So first, diba? So yung definition natin for dy dx, no? Okay? So again, so ito yung derivative, diba? So pag sinabi natin dy dx, diba? So remember that this is just the limit, diba? Okay, so ng slope, diba? So gaya ng sinabi ko kanina, yun yung pinaka-application natin dito. So kaya pwede mo isipin to as parang limit lang siya ng delta y, delta x as delta x approaches 0. So yun yung parang pinaka sinasabi ng definition niya, diba? So pero if you know the actual definition of dy dx, so that's the limit of, so if y is equal to f of x, so then this is f of x plus h minus f of x. So kaya delta y lang, no? So then this is h. So this is delta x, diba? So x plus h minus x. So this is as h approaches 0, no? So kaya pag mahilig kayo mag-derive, diba? So tapos hindi kayo mahilig mag-memorize, ito yung kailangan yung aralin, diba? So although again, so medyo mahirap yung mga derivation pagdating sa derivatives, diba? So kaya it's better to memorize, no? Okay? Okay, so again, common functions lang naman. Ano ba yung mga common functions natin? Polynomial, diba? So trigonometric, logarithmic, diba? Exponential. So yun lang naman yung mga madalas yung makikita pagdating sa board exam. Okay? Inverse trigonometric, isa din yung sa mga lumalabas sa board. Okay? So kaya, again, so try to memorize so if you can. Okay? So then, diba? So, again, yung mga rules na kailangan natin tandaan, diba? So just a recall, so alam ko naman na alam nyo na itong mga to. First is the sum rule. So isama na rin natin siguro dito yung difference. No? So sum and difference rule. Okay? So yung sa sum and difference rule lang, so is simply if you add two functions, diba? So if we get the derivative, okay? So derivative with respect to x, for example. So ng dalawang function, so f of x saka g of x. So then, so this is simply equal to, so f prime of x, no? So then plus g prime of x. Diba? So i-derivative nyo lang pareho, diba? So again, so if you're adding, okay? So yung pangalawa, diba? So is yung multiplication by a constant. Okay? So pag naka-multiply sa constant, so we just factor, diba? So derivative with respect to x, so let's say we have constant c. So then we have f of x, so then this is constant, so then multiplied by f prime of x, diba? Okay? So pangatlo, so we have yung product rule. Okay? Okay, so again, sa product rule naman is pag nag-multiply tayo ng dalawang function. So we have f of x, so then multiplied by g of x. Okay, so then this will just be given by, so we have f of x, so we have the first function multiplied by the derivative of the second function. So plus the second function multiplied by, so we have the derivative of that first function. Okay? So again, this is product rule. So huwag niyo kakalimutan niya kasi ginagawa ng mga estudyante dito, diniderivative lang nila yung f saka yung g, tapos minumultiply din nila. So again, that's not the product rule for differential calculus. No? So again, pag nagmumultiply kayo ng dalawang function, so don't forget this. Okay? Okay ba? So actually, madederive natin itong pangalawa mula doon sa product rule. Diba? So kasi derivative ng constant we know is 0. So kaya basically magka-cancel itong first term. Kaya matitira lang is yung constant multiplied by the derivative of the function. Diba? Okay? So pang-apat, okay, so is the quotient rule. Okay? So hindi ko alam kung ano yung ginagamit yung mnemonic, diba? So for quotient rule. So pero sa amin kasi, so from my college, no? So sa UP Diliman, okay? So ang tinuro sa amin dati dito is yung low D high, okay? So minus high D low over low squared, okay? So ang high is taas, low is baba, diba? So kaya low D high, so low D high, so derivative ng nasa taas, minus high D low, so f of x, g prime of x, so divided by low squared. Ang low squared is g of x, so then we have quantity. Okay? So again, so yan yung quotient rule natin. Diba? Okay? So then panglima, so we have the chain rule. So isa rin to sa mga pinaka-importanteng rule pagdating sa derivative, no? Ginagamit natin yung chain rule if we have a function inside another function, no? So kaya basta magkaroon ka ng isang function sa loob ng isang function, so then kailangan mo siyang gamitin ng chain rule. Isa din yan sa mga nakakalimutan ng mga estudyante, no? So yung chain rule natin. Okay, so yung sinasabi dito is if we have let's say g of x, okay, so dun sa loob ng f of x, diba? So then, dapat ang derivative natin dito is yung derivative ni f as a function of g of x. Diba? So then, multiply natin siya ng derivative nung nasa loob. No? So basically, magsisimula ka sa pinakalabas na function, kukunin mo yung derivative nun, then i-multiply mo siya ng derivative nung nasa loob. Diba? So, and so on. So kung medyo complicated yung function natin. No? Makikita naman natin yan sa example later on. No? So, and, okay. So number 6 is the power rule, no? So yung power rule naman so is just for polynomials, no? Okay, so kasi isa to sa mga pinaka-common na lumalabas sa board, diba? So polynomial functions, diba? So this states that the derivative with respect to x ng x to the n is simply equal to n, so then x to the n minus 1. Okay? So alam naman natin siguro itong lahat ng to. No? So okay, so na-recall ko lang, diba? So para dire-diretso tayo mamaya sa mga problems. Okay? So then, okay, so let's proceed to sa mga problem natin. Okay? Okay, so let's start with this problem here. Diba? So we have if y is equal to x to the 50, so find the 50th derivative of y, diba? So with respect to x. Okay? So now, so dito syempre, so gagamit tayo ng power rule. Diba? So kasi makikita naman natin that this is simply a polynomial. So then, gagawin natin to, kukunin natin yung derivative nito, diba? So kung hindi nyo alam yung rule dito, diba? So then just find the pattern, diba? So makikita naman natin siya during the course of our solution, diba? So kaya again, so mas maganda minsan, marunong talaga kayo mag-derivative, especially pag mga gantong uri ng problem, no? Hindi lang siya first derivative. Yung sa calculator kasi natin first derivative lang yung available, diba? So and hindi mo makikita yung doon, yung form, diba? Ang makikita mo lang doon is yung values. So yun yung isang disadvantage sa calculator method natin. Kaya kung nakaasa kayo dun para sa derivative, so pag mga ganitong uri ng problem, ay hirapan kayo pagdating sa board. Diba? Okay? So then, so let's solve this problem. So let's start with y. So again, so this is y is equal to x raised to 50. No? Okay, so then, so we try to solve. So first, we get the first derivative. No? So to get the first derivative, so just power rule. We get the exponent, diba? So we multiply dun sa function. So then yung exponent, babawasan natin ng isa. Kaya kung from 50, magiging siyang 49. Diba? So as we can notice dito, diba? So the exponent just goes here. No? So tapos nabawasan lang ng isa yung exponent natin. Diba? So kaya alam natin na pag kinuha natin yung next derivative natin, so let's say we get the second derivative. Okay, so then we can factor out the constant, diba? So using the multiplication by a constant rule. So this will be 50 multiplied by, so again, the exponent goes here. So this becomes 49, diba? So then yung exponent natin, so mababawasan na naman ng isa. So this will become 48. Diba? Okay? So kaya makikita natin the exponent decreases by 1 every time kukuha tayo ng derivative. Diba? So nung first derivative, nabawasan na siya ng isa. Nung second derivative, nabawasan na siya ng dalawa. So kaya we can assume, diba, or we can conclude, diba, na pagdating natin sa 50th derivative, yung exponent natin mababawasan na ng 50. Diba? Kaya from 50, magiging siyang x to the 0. Diba? So we get that if we get the 50th derivative, okay, okay, so then this will be given by, okay, so we have 50, start tayo sa 50. So then we have 49. So and meron pang mga naka-multiply na constant dito kasi bawat isang exponent na nakukuha natin ang multiply siya. So every time we get the derivative, diba? Mas alam natin sa bandang dulo nito magkakaroon ka ng x to the 0. But again, so yung x to the 0 natin, diba? So is just equal to 1, diba? So from raised to 48 magiging siyang x raised to 0, diba? So but again, we know that this is 1. Okay? Okay? So kaya we can just cancel that part, no? So how about the constants, no? So again, so remember na every time na nagde-derivative tayo, yung exponent na mo-multiply as a constant. diba? Or as a coefficient, okay? So kaya alam natin dito sa third derivative, yung 48 naka-multiply na dyan, diba? So tapos, pagdating natin sa fourth derivative, yung 47 na kasunod, naka-multiply na rin. So kaya basically, yung constant term natin dito is 50 times 49 times 48. Tapos pabawas lang siya ng pabawas. Diba? So yung tanong is, saan ito matatapos? Diba? So up until anong number. Diba? So again, as you can see, we know na matatapos to sa x to the 0. Kaya alam natin before this is x to the 1. Diba? So ibig sabihin yun na multiply dito na constant is 1. Okay? So kaya alam natin that this is simply the definition of the factorial. Diba? So n factorial is defined as, so n times n minus 1. So again, this is a note. Okay? So then this is times n minus 2. So pabawas lang siya ng pabawas ng isa until umabot tayo sa 1. Diba? So kaya alam natin that this is a factorial. So therefore, we write this as 50 factorial. So this is our 50th derivative. No? Okay? So kaya we have letter B. Okay? So kaya from here, so we can conclude, diba? So that if, okay, so y to the n, y is equal to, so x to the n, diba? So and, okay? So again, so if y is equal to x to the n, diba? So and if we get the nth derivative, so again, starting from the first derivative by power rule is this one. So then second derivative by power rule is n times n minus 1 times x to the n minus 2, so and so on. So then for the nth derivative, diba? So then this will be given by, okay, so we have n, so times n minus 1, and so on. So again, hanggang umabot to ng 1, then x to the 0. But again, x to the 0 is 1. So therefore, so the nth derivative is given by n factorial. Okay? Okay ba? So again, so yan yung isang direct formula na kung gusto nyo aralin, pwede nyo memoryahin, diba? So although hindi ko siya recommended kasi bihira naman lumabas yung mga gantong tanong sa board, no? Or if ever na may lumabas na gantong specific na tanong, diba? So isa lang siguro or dalawa lang pagdating sa board exam, diba? Okay? So kaya mas maganda alam niyo yung process paano natin nakuha yung direct formula. No? Okay? So we just use power rule, diba? So multiplication by a constant. So pagdating dun sa mga rules natin sa derivative. Okay? Okay? So any questions para dito? So guys, so if you have questions, just raise your hand, no? So or message me privately, no? Okay? So pwede rin to everyone. So kung gusto niyo makita ng everyone yung message nyo. Okay? So yan. So para masagot ko yung mga questions, no? Diba? So during lecture. Okay? So then, so let's move to the next problem. Okay, so problem number 2. No? So find y is equal to arctan so of ln x, diba? So find y prime when x is equal to 1 over e. No? Okay, so first let's try to solve this using our basic concepts. No? So actually madali lang yung mga gantong uri ng problem. So basta alam nyo yung derivatives ng mga functions na nakalagay dyan. Okay, nakuha ba? So ito yung sinasabi ko sa inyo kanina, so na gagamitan natin ng chain rule. Diba? So makikita natin that this is medyo complicated yung function natin kasi meron kang ln sa loob ng arctan. Okay? Nakuha ba? And yung ginagawa kasi ng mga estudyante dito, yung nasa labas lang yung kinukunan nila ng derivative. Nakakalimutan nila yung nasa loob. Diba? So yun yung reason kaya madalas nagkakamali yung mga estudyante sa mga ganitong problem. Especially kung nag-basic concept sila sa problem. Okay? Nakuha ba? So, yan. So, although pwede naman natin itong isolve sa calculator. So, pero sa multivector kasi, so lagi ko sinasabi sa mga estudyante na during review, no, huwag kayong gagamit ng calculator method or calculator technique. Diba? So, during exam, okay lang. Okay? Nakuha ba? So, kasi mapapabilis naman talaga nung calculator method natin minsan yung pagsusolve natin sa problem. Okay? So, pero during review, it's better to practice na so solving manually, diba? Solving by hand. Okay? So kasi mapapabilis niyo yung thinking process niyo, diba? So pag nakita niyo yung isang problem, diba? So tapos na-practice niyo siya by hand, diba? So then parang meron na kayong idea sa magiging flow ng solution niyo, diba? So yan, at some point, diba? So habang nagsasagot kayo ng problem, habang nagsusulat kayo ng solution, nagsosolve na rin yung utak nyo nun. Okay? Okay? So then, mas mapapabilis nun yung solution nyo, diba? Especially kung i-incorporate nyo pa siya sa mga alam yung calculator method. No? So kaya during review, so try to practice by hand. No? Okay? Okay? So tutulungan naman kayo ng mga nagtuturo sa inyo usually, diba? So pag nahihirapan kayo sa mga subjects. Okay? So or dun sa mga topics. Okay? Okay? So, yan. So, or try to get a hold of contacts ng mga nagtatop, diba? So, sa board exam. Okay? Karamihan naman sa kanila mababait na pag nag-chat kayo na nagtatanong kayo ng problem, so magre-reply naman sila. No? Okay? So, kaya, syempre pag may time lang sila. Okay? So, pwede rin kayo magtanong doon. So, or sa mga classmates nyo, diba? Okay? So, yan. So, let's try to solve this one. So, again, so we'll solve this by hand first, no? Kung nalilito kayo sa simula, diba? So, pwede kayong gumamit ng substitution, diba? So, magle-let muna kayo ng value. No? So, for example, kayo sa dito, so, ang given sa atin is ganito. So, we have y is equal to arctan, diba? So, arctan, so, of ln of x. Okay? So, yun yung given sa atin. Okay? So, let's try. Okay? So let's try, diba? So using substitution here, no? So akin papakita ko muna sa inyo yung long method, tapos mamaya try natin yung diretso lang, no? So kasi makikita niyo na simple lang din pag diniretso natin sa chain rule. Okay? So pag nag-let ako dito, so let u, for example, diba? So u is equal to, diba? So yung nasa loob, so ln of x. Okay? Okay? So then we can say that du dx, okay? So is simply equal to, so we have 1 over x. Diba? Okay? So again, so ito yung direct formula natin para sa derivative ng natural logarithm. No? So again, so tandaan nyo yan. So kasi isa sa mga madalas lumalabas sa board sa derivative is the natural logarithm. No? Okay? So then, so again, ang gusto natin ma-solve is y prime. So we know that y prime is dy dx. Diba? So and by the way, so ito, so since pinalitan na natin yung u ng ln x, magiging na tong y is equal to, so arctan. Okay? So this will be arctan, okay, so of u, di ba? Magiging na siyang arctan of u. Okay? Okay ba? So then, okay, so unahin siguro natin yan. So ilagay ko na siya dito. So again, so by substitution, so then yung y natin so will become so arctan of u. Diba? So therefore dito yung dependent variable natin is y, the independent variable is u. So again, in terms of this function, so therefore, so let's try to get dy du. So pwede natin gamitin yung direct formula for arctan. Diba? So for arctan, so ang derivative ng arctan is given by 1 over 1 plus yung variable natin, so which is u. So this quantity squared. Okay? Okay ba? So therefore, so if we want to get y prime, okay? So again, so y prime natin, so is simply dy dx, no? But as you can see, so wala pa tayong dy dx dito. So kaya ang gagawin natin dito, magmo-multiply tayo dito ng du over du, diba? So ito yung basis ng chain rule, basically, no? Pag nag-multiply tayo ng du over du, you can imagine na parang nag-multiply lang tayo ng 1, diba? Kasi du divided by du is 1, diba? Okay? So kaya pwede natin tong gawin. Ang pwede natin gawin dito is so pag palitin natin yung nasa fraction natin. So we will partner this with this one. So dy du, diba? So and we will partner this with this one. So we have du dx, diba? Okay? So therefore, pag ginawa natin yan, so this will be dy du multiplied by, so we have du dx, diba? And alam naman natin yung dy du. So dy du is this one. So we have 1 over, so we have 1 plus u squared. Diba? So then multiplied by du dx, that's 1 over x. Okay? Okay ba? So now let's evaluate this. Kasi meron naman tayong value ng x. Diba? So at x is equal to 1 over e. So let's calculate yung u. Diba? So ang u natin is ito. So kaya from here, so we can see that u is equal to ln, so ng 1 over e. So pwede nyo itong idiretso sa calculator, or if you realize, diba? So that 1 over e can be written as e to the negative 1. So then properties ng logarithm, we can cancel this, diba? So we can say that u is equal to negative 1. So by substituting here, so we have 1 divided by, so we have 1 plus negative 1 quantity squared. So this is multiplied by, okay? So we have 1, so over 1 over e, diba? So then this will be given by, so reciprocal ng 1 over e is e. So then this is 1/2. So therefore, this will be e over 2. Okay, so this is our y prime. Okay? So kaya yung sagot natin dito is letter E. Okay? So any questions? So para sa problem natin. So again, so ito yung, kumbaga parang ito yung pinanggalingan ng chain rule. Diba? So itong concept na ginawa natin dito. Diba? So kaya madali natin nakuha yung sagot. Diba? So but again, so if you know chain rule, diba? So pwede natin idiretso yan sa chain rule. Diba? So another method or another solution. Diba? So para sa problem. Okay? So kung iisipin natin, for example, yung f of x natin. Okay? So let f of x, no? Okay, so be equal dun sa arctan. So let's say ito yung arctan of x, no? So again, so remember, this is function of x. So kaya arctan of x yung ginamit natin as our variable. But as you can see dun sa given sa atin sa problem, di ba? Instead of using x, ang makikita natin sa loob ng arctan is ln x, di ba? So ibig sabihin yun yung function na pinasok natin sa f of x, di ba? So yun yung tinatawag natin na composite function, di ba? So we have g of x, okay? So is yung nasa loob, that's ln of x. Okay? Okay ba? So kaya from here, okay? So alam natin na yung f prime of x, diba, is simply equal to, okay? So we have, again, so alam natin yung direct formula for arctan. That is simply 1 over 1 plus x squared. So palitan nyo lang yung variable ng x, diba? So then ito naman, diba? So we can say that g prime of x, so again for ln, that's 1 over x. So therefore, this is 1 over x. Okay? So this is 1 over x. No? Okay? So again, so yan yung basic, yan yung mga basic functions natin, di ba? So within dun sa given sa atin. So now, so for the composite function, alam natin yung ln x, di ba? Okay, so itong ln x na to, so basically pinalit lang natin siya dun sa x. Diba? So kaya ibig sabihin yung x na to, so since ln x is yung g of x, so basically itong g of x na to, parang pinasok lang natin kay x. Diba? So therefore, yung composite function natin, so will become f of g of x. Diba? So pag ginawa natin yan, so papalitan natin yung x ng ln x, so then we get this is arctan of ln x. Okay? Okay ba? So yun yung composite function natin. So which is basically the same as yung given sa atin sa problem. Diba? So now, by chain rule, okay? So this is by chain rule. Okay, so what we know, diba? So is f prime, okay, so of g of x, diba? So is simply equal to, okay, or so let ko siya this way, no? So derivative with respect to x, no? So ng f of g of x, okay? So again, so by chain rule, so alam natin na ito ay derivative ng f, pero papalitan natin yung x ng g of x, diba? So kaya basically, so itong g of x natin, diba? So again, so para dito sa f prime of g of x, ipapasok natin siya dito sa x na to, diba? So or ipapasok natin to, so dito sa x na to, no? Okay? So yun yung nangyari dyan. So kaya sabihin tong x na to, papalitan lang natin ng g of x, which is ln x. No? Okay? So and, so then that's multiplied by, okay? So this is multiplied by, so we have g prime of x. Okay? So ito na yung g prime of x mismo. Diba? So by using that, okay, so then this will be 1 over, okay, so this is 1 plus ln x. So this quantity squared, no? So then this is multiplied by, so again, g prime of x is 1 over x. Okay? Nakaba? So by substituting, x is equal to 1 over e. So remember, ito na yung y prime natin. So kasi ito yung y. Diba? So ito yung y. Diba? Okay? So kaya by substitution, diba? So yung y prime natin will become, so this is 1 divided by, okay, so we have 1 plus, so this is ln ng 1 over e, So this quantity squared multiplied by 1 over 1 over a. Okay? Okay ba? So again, so if you try to solve this, you will also get e over 2. So again, so ito yung lalabas na y prime natin. So as you can see, so we have the same answer. Okay? So ngayon, diba? So kung sanay na kayo sa chain rule, so again, so no need to undergo this method na ginawa ko dito. Okay? So pwede na kayong dumiretso kagad dito. Diba? So just imagine, so again, anong derivative ng arctan? So ganito. Ganito yung derivative ng arctan. Diba? Palitan nyo lang yung x nung nasa loob. Diba? Okay? So tapos, after nun, i-multiply nyo lang siya ng derivative nung nasa loob. Diba? So which is naka-multiply siya dun sa 1 over x. Diba? So ganyan lang yung chain rule. Diba? So kung sanay na kayo sa paggamit ng chain rule, diba? So again, so no need to undergo this substitution part. Okay? Diba? So basically, so if you know that y is equal to arctan, diba? So of ln of x, so then we can say, diba? So na pag diniretso ko to sa chain rule, so again, alam natin na yung arctan is 1 over 1 plus x squared. So yung x, palitan mo lang ng ln x. So then ln x, so this quantity squared. No? Okay? So then, so this is multiplied by, okay? So derivative ng nasa loob. Derivative ng ln x is 1 over x. No? So diretso na kagad tayo dito. Diba? Okay? So kaya guys, so kaya nasabi ko na simple lang din yung chain rule kung iisipin. Diba? So basta alam nyo lang yung concept, diba, sa behind chain rule. Okay? So pag yung composite function natin is meron pang mga ibang function sa loob, diba? For example, instead the ln of x, nagitong ln of 2x, i-multiply nyo lang din dito yung derivative ng 2x. No? Okay? So tapos ito magiging 2x to. So ito magiging 2x to. Ito magiging ln of 2x. Diba? Okay? So kaya basically, again, start kayo sa labas, tapos unti-unti kayong papasok sa loob. Diba? Sa pagkuha ng derivative sa chain rule. Okay? Okay ba? So pero gaya ng sabi ko sa inyo kanina, diba? So there's another way, diba? So to solve this problem, diba? So and that is by using your calculator, diba? So pero actually hindi ko to nire-recommend pag nagre-review kayo, diba? So kasi magde-deteriorate, diba? So yung basic concepts niyo pag lagi kayong gumagamit ng calculator. Kumbaga pag nakalimutan niyo kasi yung basic concepts, diba? So pag konting tweak lang dun sa problem, for example, instead of the first derivative, second derivative na yung kailangan yung kunin, diba? So then, hindi nyo na siya masolve sa calculator kasi wala naman second derivative sa calculator. No? Okay? So now, regarding sa ginagamit kong calculator, so I'm using 570 ES+, no? So yun kasi yung isa sa mga madalas gamitin ng mga electrical engineering student. Okay? So pero alam ko sa CE, sa civil ata hindi pwede yung 570 ES+. So pero hindi ko alam kung nagbago na yung ruling nila. No? Okay? So kaya explain ko na lang sa inyo kung ano yung ginagamit natin mga functions. Okay? So para kung iba yung gamit nyo na calculator, so then hanapin nyo na lang yung specific function na yun sa calculator nyo. No? So again, so dito sa 570 ES+, so pwede kayong mag-derivative. Okay, nakuha ba? But as you can see dun sa pagkakasulat niya dito or pagkakalabas niya dun sa screen, meron dito nakalagay na x is equal to something. So ibig sabihin, we need to evaluate the derivative. So kaya maganda itong gamitin pag mga gantong uri ng problem kung saan ini-evaluate natin yung derivative at a specific value. Diba? So although the problem here is, okay, so yung choices natin are in terms of the natural number e. Diba? So kaya ibig sabihin, hindi ganyan yung lalabas sa calculator. Ang lalabas sa calculator is nakadecimal. So kaya kailangan nating evaluate lahat ng choices. No? Okay, nakuha ba? So kaya medyo hahaba yung solution sa dahil doon. Okay? So although since nasa letter A naman yung E over 2, so then maikli lang din yung kalalabasan. Kasi most likely ito yung uunahin yung i-evaluate. Diba? Okay? So pero anyway, diba? So again, so pwede nyo gamitin to. Diba? So meron naman derivative dyan sa calculator nyo. So again, so if you are using different models, hanapin nyo lang yung derivative dun sa calculator. So pag hindi nyo alam paano gamitin, hanapin nyo yung manual ng calculator nyo. So available naman usually online. So para malaman nyo paano mag-derivative dun sa ginagamit yung model ng calculator. No? So hindi ko kasi alam kung pwede to sa ibang courses. No? So pero sa electrical engineer, so tinatanggap to. Diba? So first edition or second edition ng 570 ES Plus is tinatanggap na. So itong ginagamit kong software dito, so itong simulator na to, this is 570 VN Plus, no? So although hindi to pwede sa board exam, pero nandito kasi lahat ng functions ng 570 ES Plus. And pareho lang naman yung location niya, so kahit ito na yung ginagamit namin sa review. No? Okay? So again, so derivative, so just input the given. So arctan is the inverse function of tangent. So dito sa calculator, makikita natin siya as tan to the negative 1. Diba? So shift. So then yan. Okay, so ito yung arctan na tinatawag. No? So then this is arctan of ln of x. So then we press ln. So then alpha x. Diba? So then close parenthesis. Another close parenthesis. And again, this is evaluated at 1 over e. So kaya 1 over. So dun sa e, pwede natin gamitin tong alpha. So may e dito na kulay pula, diba? So pwede yan. So pwede rin namang shift, tapos itong e to the something, tapos gawin nyo lang e to the 1, diba? So kahit alin dyan, pwede nyo gamitin. Okay? So we get, kailangan natin lumipat sa regions, no? Okay? So yung nakukuha kasi dito is naka-degree, diba? So pero, so para safe kayo, when you are using derivative saka integral sa calculator, so make sure na naka-regions kayo. Okay? Naka ba? So another way so to make these regions is just shift. So then yung DRG, so dun sa calculator, so then piliin nyo lang itong regions. Okay? So arctan to. So yung sabihin, angle yung magiging sagot dito, so which is in degrees. Diba? So kaya lagyan nyo lang ng R. Diba? So to specify sa calculator na naka-regions yung value niya. No? Although, babalik lang ata ito sa degree. So, let me change na lang yung setup. So, gawin natin itong regions mode. Okay? So, pag naka-regions mode yan, so then, so regions na yung lalabas. Okay? So, pag naka-degree kasi, degree pa rin yung lalabas, even though i-declare natin siya as regions. So, kaya gawin na lang natin regions mode. Diba? So, we have 1.359. Okay? So, then, so ang kailangan na lang natin gawin so is evaluate yung choices. Pero since alam naman natin na E over 2 yung sagot, so then E over 2 na lang evaluate ko dito. So we have E divided by 2, so we have 1.359 as well. So makikita natin pareho lang yung lalabas sa sagot. No? Okay? So although again, diba, mapapansin natin na hindi natin alam yung form. Saan nakuha itong 1.359? Diba? Kaya pag second derivative yung hinahanap, diba? So then, after the first derivative, so wala na tayong masasolve. Diba? Okay? So kasi in-evaluate na natin yung derivative natin. Okay? So kaya pag mga second derivative, third derivative, so we cannot use this. Diba? Pag partial differentiation, so we cannot use this. Diba? So and so on and so forth. Okay? So kaya mayroong mga limitation. Diba? So yung mga calculator method natin. So kaya gaya na sabi ko sa inyo kanina, it's better to understand the basic concepts, diba? Kasi pag alam niyo yung basic concept and marunong kayong gumamit ng calculator, so kayo na mismo yung discover ng mga calculator methods, diba? Or calculator techniques, diba? And syempre, hindi niyo makakalimutan yun kasi kayo naka-discover na, diba? Okay? So, any questions for this part? Okay. So, let's try number 3, diba? So, number 3, as you can see, ito yung ginamit nating first solution. So, dun sa problem number 2. So, kaya basically parang chain rule din lang yung gagawin natin dito. Diba? Okay, so let's try this. Diba? So, let's start with y. So, again, y is given by, so this is u cubed plus 4. No? So, then if I get dy du, so then this will become, so we have 3u squared. Derivative ng constant ay 0. So, kaya 3u squared lang ilalabas dito. So, this is 3u squared. Okay? So the next, diba? So as yung given sa atin na u is equal to x squared plus 2x. So we get the derivative of u. So with respect to x, so then this is equal to 2x plus 2. Okay? So then we can simplify this, diba? So by factoring out 2. So then this will be 2, so times x plus 1. So this is our du dx. Okay? And as you can see, diba? So from the choices are in terms of x. Kaya ibig sabihin, kailangan natin itong gawing in terms of x. So therefore, itong u na to, ipapasok natin ngayon dun sa equation natin. No? So this will be 3. Okay? So I think it's better kung i-factor out muna natin to. So we have x multiplied by x plus 2. Diba? So then this will be 3 multiplied by x plus 2. So then this quantity squared. Okay? So this will be given by, okay, so we have 3x squared multiplied by, so x plus 2 quantity squared. So again, so this is our dy du, no? So again, so what do we want to solve here? So what we want is dy dx. So again, so kagaya ng ginawa natin kanina, so to solve for dy dx, no? So ang gagawin lang natin is i-multiply lang natin siya ng du over du. Diba? So by doing so, pag pinagpalit natin yung dx saka yung du dito, so you will get dy over du multiplied by du over dx. So i-multiply lang natin tong dalawang to. No? Okay? So this will be 3x squared multiplied by, so x plus 2, so quantity squared, multiplied by 2, multiplied by x plus 1. So then this will be given by 6x squared. No? Okay, so tapos we have x plus 2, quantity squared, multiplied by, so we have x plus 1. So this is our final answer. So again, so since pinaghiwalay na dito sa problem na to yung y saka yung u, diba? So pinaghiwalay na tong dalawang to. Okay? So okay, it's better to solve this problem, diba? So this way. Okay? Okay, so mas diretso siya. Diba? So pero kung gusto nyo gamitan ng chain rule na ginawa natin kanina, so pwede naman. So ipasok nyo kaagad to dun sa loob, so then saka nyo gamitan ng chain rule. Diba? Okay? So yun yung isang solution. But again, so this is more straightforward. So kaya ito yung ginamit natin solution sa problem. So we have 6x squared, x plus 2, quantity squared, so then x plus 1. So we have letter B. Okay? So any questions para dito? So again, so yan yung solution natin. Okay. So again, so another way is by using chain rule, diba? So pero kayo na yung bahala kung gusto nyo gamitin to. So palitan nyo lang kagad yung u dito, diba? So nung x squared plus 2x. Okay? So again, as you can see here, so itong u na to, pinasok lang natin dyan. So then cubed plus 4. So then by using chain rule, so kung i-diretso natin to, so derivative to ng parang x cubed, diba? So that's 3x squared. So ibig sabihin this will be 3 multiplied by kung ano man yung nasa loob. Tapos yung exponent, babawasan natin ng isa, diba? So power rule lang to. Diba? So then, pero since hindi x yung nasa loob, that's another function, we multiply this by, so kung ano man yung derivative ng nasa loob. So that's 2x plus 2. So then, we can factor. So we can factor x here. Diba? So then this will be x plus 2, quantity squared. We can factor 2 here. So then we have x plus 1. So then you will get this is 6x squared. So then x plus 2 quantity squared. So then x plus 1. So this is our final answer. So again, same one. Diba? 6x squared, x plus 2 quantity squared, x plus 1. Okay. So any questions para dito? Okay. So now, diba? So again, so let's try, diba, solving this using the calculator, no? So kanina, diretso lang, so yung ginawa natin, so as you can see here, diba? So nung ginamitan natin ito ng calculator, so diniretso na natin to, tapos pinalitan lang natin yung x ng 1 over e, tapos nakuha na natin yung sagot, diba? So ang difference niya dun sa problem number 3 natin, is dito sa problem na to, yung choices natin is yung form, yung hinahanap, diba? So not the actual value. Okay? So kaya ibig sabihin, 'di ba? So hindi natin magagamit diretso yung calculator, 'di ba? Kumbaga pag meron tayong nakuha sa calculator, so hindi pa 'yun yung hahanapin natin sa choices. So we need to do something first, okay? Nakuha ba? So para mangyari 'yun. So akin para magamit natin yung nasa calculator, so remember, kailangan natin ng point kung saan natin i-evaluate, 'di ba? So yung ating derivative, okay? Nakuha ba? So therefore, kailangan muna natin maghanap ng value ng x, diba? So kung saan natin siya i-evaluate, diba? Okay, so let's say we have x, no? So ngayon, pagpipili kayo ng value ng x, diba? Sa calculator. So again, so huwag kayong pipili ng number, diba? So kung saan magiging redundant yung choices, diba? So paano magiging redundant yung choices, diba? So meron kang choices, diba? Or merong dalawa sa choices, diba? Or 2 or more sa choices, diba? So na magpapareho yung value, okay? Kasi pag ginawa natin yon, so then mababaliwala yung solution natin. So kasi dalawa yung lalabas na possible na sagot sa choices, so then uulitin lang natin uli yung method, diba? So which is a waste of time, diba? So for example, ginawa ko tong x is 0. So again, so ito waste of time to. So kasi pag ginawa natin to, makikita natin lahat ng choices magiging 0, diba? So dahil sa factors na to. Okay? So you will get 0 lahat yan. Diba? So kaya ayaw natin mangyari yan. Diba? So kasi basically wala tayong mapipiling sagot kasi lahat naman sila magiging 0. No? So and wag din kayong pipili ng mga complicated numbers such as decimal numbers, fractions. Diba? So as much as possible, positive integer yung piliin nyo. Diba? So ang gagamitin ko dito is 1. So I think 1 is fine. No? So let's try to solve this if x is equal to 1. So if x is 1, this is 1, this is 1, this is 1, this will be 1. No? So we have 6. This is 3 squared is 9. No? So times 2 is 18. So 18 times 6 is 108. No? So this will be 108. So again, if x is equal to 1. Diba? So 6 times 9, 54 times 2, 108. Tama. Okay? So if x is 1, so this will be 1, this will be 1, this will be 1. Diba? So that's 3 squared is 9 times 3 is 27 times 2 is 54. So this will be 54. So this will be 1, this will be 1, then this will be 1. No? So 3 squared is 9 times 3 is 27. So times 2 is 54. So again, so this is a so this is a problem, diba? So kasi dalawa sa kanila yung 54. So although hindi naman natin siya magiging problem dito sa problem na to, dito sa question na to kasi alam naman natin letter D yung sagot. So kaya ibig sabihin either B or C yung neither B nor C yung makukuha natin sagot dito. So kaya actually okay na tong x is equal to 1, diba? So pero again, so para makita nyo rin, diba? So let's choose another value of x, no? So again, so ang importante kasi dapat wala magpapareho sa choices. Kasi pag nagkataon na yun yung tamang sagot, diba? So then, dalawa pa yung pamimilian nyo. So kaya uulitin nyo na naman yung process, diba? So kaya yun yung ayaw natin mangyari. So let's try x is equal to 2, no? So again, so palitan nyo lang yung x ng 2, diba? So then, so let me open my calculator, no? Okay? So ang ginagawa ko dito dati nung nagre-review ako for the board exam. So pag mga gantong parts, diba? So na maraming variables na nakalagay, no? So ang ginagawa ko lang is ini-input ko lang yung variables na yan. So again, so we have 6x squared. So then we have x squared. Okay, so then plus 2x. Okay? So again, ito yung letter A, no? So we have 2x quantity squared. So times alpha x plus 1. Okay. So yan yun, no? So we have 6x squared plus 2x quantity squared. So then x plus 1. So then I just press this calc button, no? So tapos hihingi lang siya ng value ng x. So again, so we will choose x is equal to 2. So then I will choose 2, diba? So then equals. So then i-evaluate na siya, diba? So this is 4,600. Okay? So yung advantage ngayon nito, okay? So yung advantage kasi nitong calc method, diba? So over dun sa basta lang natin iso-solve, diba? So kailangan pa natin maglagay ng parenthesis, diba? So pag mag-multiply tayo or we will use the multiplication button, diba? So which is basically parang extra time, okay? No, ba? So since sanay naman tayo mag-alpha x, diba? So dun sa calculator, diba? So and kung kailangan nating ulitin, so for different value of x, so then we will just need to press another calc, diba? Medyo mas madali siyang i-edit kasi halos pare-pareho naman yung form nung nasa choices. For example, dito papalitan lang natin to ng 3. So tapos tatanggalin lang natin yung x dito. Diba? Okay, so then yun na yun. So then calc na lang uli. So then equals. So then we have 1,296. Diba? So this is 1,296. Okay? So for letter C naman, so ganun ulit, 3x squared. So x plus 2 na lang to. So ganyan. So then calc. Okay, so equals. So we have 576. Or actually kahit pagdating dito, since yung nasa value ng x natin is 2, diba? So pag nag-calc kasi tayo 2 na yung nakalagay dyan, so automatically kasi nakasave na yan dun sa x. No? So kaya kahit hindi na natin gawin yan, so hindi naman natin pinapalitan yung x, if I press equals, yun na rin mismo ilalabas sa sagot. No? Okay? So yun yung maganda dun sa calc method, okay, so of the calculator. So maganda rin siyang gawin pag nagka-trial and error kayo, diba? So or pag nag-numerical methods kayo, no? Okay? So yan. So pero kayo na yung bahala mag-explore for that one, no? So let x is equal to 2, diba? So then this is 576, okay? And sa letter D, ang nagbago lang dito is yung 3 naging 6, diba? So kaya palitan lang natin ito ng 6, press equal, so we have 1152. No? Okay? So then, the goal, diba? So, or the idea, so is if I get the derivative, so of the function, diba? Evaluated at x is equal to 2, diba? So then dapat isa dito yung mapapalabas natin sa diba? So let's try that. So again, so ito na yung gagamitin ko, diba? So ipapasok na natin yung u dun sa y para magamit natin yung calculator. So yung calculator kasi one variable lang yung kaya niya i-solve. So kaya dapat dalawang variable lang involved, diba? So that independent and the dependent variable, diba? So kaya dito, so we have y is equal to, okay, so x squared plus 2x. So this quantity raised to the third power, so then plus 4. No? Okay? So yan, diba? So then, so kailangan lang natin kunin yung derivative ng y. So with respect to x, so then we will evaluate this at x is equal to 2. No? So again, so try natin itong i-solve using the calculator. Okay? So again, so derivative. So ipasok lang natin tong equation natin. So we have alpha x squared. So then plus 2 alpha x. So this quantity raised to the third power. So then plus 4. So evaluate this at x is equal to 2. So if I press equal, so we get 1,152. So luckily for us, isa lang sa choices yung may 1,152. Diba? So and it matches yung na-solve natin kanina using chain rule. No? Okay? So ay depende na sa inyo. No? So kung anong gusto nyo gamitin na solution. Okay? So pero sa akin personally, I prefer chain rule. So even though alam ko tong calculator method na to, mas mahaba siya para sa akin compared dito sa chain rule. Kasi yung chain rule, ano lang, diretso lang. Diba? So kagaya nung ginawa natin dito, so diretso lang, 4 steps lang. Diba? Nakuha na natin yung tamang sagot. And actually, pwede nating skip to. So kung marunong kayo mag-mental math. Diba? So kasi nung finactor out natin yung 2 dito, pwedeng i-multiply nyo kagad sa 3, kuha kagad yung 6. Factor out mo yung x dito, so then squared. So then kuha nyo kagad to. Pag finactor out yung x dito, matitires x plus 2 squared. So then dito naman, pag finactor out yung 2, matitires x plus 1. So kaya basically 3 steps. Tapos nyo kagad yung problem. Diba? Or 4, kasi meron pa tayong ginawang substitution. Diba? Okay? So kaya mabilis lang yung chain rule. Diba? So pero sa calculator, mahaba kasi itong method na to kung isipin. Kasi after ng substitution, so then input nyo sa calculator, then iisa-isahin nyo yung choices. Diba? And again, pag ang nangyari is meron pang naulit dun sa choices, meron parehong value na lumabas, so ulitin nyo na naman yung process. Diba? Kaya siya tinatawag na trial and error. Diba? Okay? So kasi tinatry nyo lang siya, so every time, diba? So then pag nag-succeed, saka nyo lang makukuha yung sagot. Okay? Okay ba? So any questions dito? Okay. Okay? So next problem, so number 4. Okay? So ito naman, so dito gagamit tayo ng tinatawag natin na implicit differentiation. Okay, nakuha ba? Pag sinabi natin, ang pinagkaiba ng dalawa, di ba, yung explicit differentiation and the implicit differentiation. Sa explicit differentiation, we are separating one of the variables and we are getting the derivative of that variable. Di ba? So like yung ginagawa natin dito. Di ba? So naka-isolate yung y, so then we solve for dy dx. Okay? So that's explicit differentiation. Pero pag implicit differentiation, hindi na natin kailangan i-rearrange yung equation. We just get the derivative. Okay? Nakuha ba? Then we apply so kung ano man yung applicable so na rule so dun sa kinukuha natin ng derivative. So basically parang buong equation na yung diniderivative natin, we just get the derivative of both sides. Diba? So the idea is basically if, for example, y1 is equal to y2, diba? So then, so yung dy1 over dx is just equal to dy2 over dx. So parang ganito lang yung idea ng implicit differentiation. We get the derivative of both sides and kung equal yung dalawang side na yun, dapat equal din yung derivatives nila. Diba? Okay? And kung equal yung derivatives nila, diba? So then we can just solve them. Diba? So apply kung ano man yung rule yung applicable, then hanapin lang natin si y prime. Diba? So or kung ano man yung gusto natin i-solve the derivative, so then we isolate that. Diba? So kaya basically, so we get the derivative of the whole equation first. So then, next is algebraic manipulation na lang. No? So so ito hindi nyo ito masasolve using the calculator. Okay? Okay ba? So bakit hindi ito kaya using the calculator? Kasi sa calculator, kailangan explicit. Diba? So remember, so pag nagka-calculator method tayo, so if I press the derivative here, diba? Okay, so shift derivative. Okay? So then makikita natin dito na kailangan nandito yung function natin. Kailangan nakahiwalay yung function ng dependent variable natin. Kaya again, so this is explicit differentiation. So walang implicit differentiation sa calculator, no? Okay? So let's try to solve this one. Okay? So again, so sa implicit differentiation, so meron tayong dalawang way, 'di ba? So para ma-solve 'to, okay? So one way is by using ordinary differentiation or ordinary derivative. So ordinary derivative, pwedeng kunin nyo lang basta yung derivative with respect to x, 'di ba? Para automatically y prime kaagad yung makukuha nyo, or you just get the differentials. So magiging siyang in terms of dx saka dy, tapos kunin nyo lang yung dy divided by dx, 'di ba? So ako personally, so mas gusto ko pag y prime yung sinosolve, dy dx, 'di ba? So mas gusto kong gawin solution yung derivative kaagad with respect to x, no? So kasi pareho lang naman yung mangyayari, and medyo mas nagiging komplikado pa siya pag in terms of dx saka in terms of dy, 'di ba? Pero pag mga differential equation yung pinag-uusapan, tapos gusto nating sagot or form is naka in terms of dx or in terms of dy, or pagdating sa mga approximation of error, so then gumagamit ako ng differentials. No? Okay? So again, so yun yung ginagawa ko dati nung nag-review ako. So kaya dito, so let's try to get the derivative of both sides. No? So kunin natin yung derivative of the left-hand side. So that's x cubed minus 3xy. So then plus y cubed. No? So again, so dito pagsasama-samahin natin yung mga rules. Diba? So na applicable sa problem. Okay? Nakaba? So kaya follow nyo lang. No? Okay, so first, so dito gagamit tayo ng sum rule. So again, so para kukunin lang natin yung derivative nito mga terms na to, tapos we just follow the operation, diba? So unahin natin to. Okay, so derivative ng x cubed, gagamitan ko lang ng power rule. So this will be 3, so then x, 3 minus 1 is 2, so we have 3x squared. So then multiplication by a constant, so we can factor that out. Then product rule, so by product rule, that will be x. Derivative ng y with respect to x is y prime. Diba? So yung y prime natin dito, so let y prime, so ito na mismo yung dy dx. No? Okay, so kaya yun yung dy dx natin. So then plus, so y, derivative ng x with respect to x is 1. So therefore, this is y multiplied by 1. So then we have plus, okay? So again, y cubed, so by product rule, so that is 3y, by power rule, that is 3y squared. Diba? So but remember that this is with respect to x. And this is a different variable, that's why. So kaya ibig sabihin, gagamitan natin ito ng chain rule. Kumbaga yung y, pinasok natin kay x. Diba? So therefore, multiplied by the derivative of y with respect to x, that's y prime. So ay magkakaroon ka dito ng y prime. Diba? So then derivative ng constant is 0. Okay? So you can imagine na pag ginawa natin itong in terms of differential, so kailangan nyo lang itong i-multiply ng dx. Diba? And pagdating dito, so instead na maging y prime to, this will be dy. Diba? So derivative ng y will be dy. So plus y, derivative ng x will be dx. No? Okay, so then plus 3y squared, derivative ng y will be dy. No? So kumbaga wala lang siyang with respect. No? So ito kasi merong with respect to x. Diba? So pero pag differential lang yung kukunin natin, so basically so we have this dx here. No? Okay? So kaya i-multiply natin siya sa differential ng variable na ginamit na sa term. Okay? So kaya ganito yung nagiging format natin. So you can imagine that if we divide this by dx, this will cancel. Diba? So kumbaga yun yung over dx dito. So this will cancel as well. Diba? Tapos ito magiging dy dx, ito magiging dy dx. Diba? That's y prime. So kaya basically babalik tayo dito sa equation na to. Diba? So kaya para hindi ko na kailangan mag-divide ng dx dyan, so then diretso na tayo sa derivative. Okay? So kaya depende sa problem, diba? So kung ano yung gusto nating preference, diba? So sa pagsosolve natin. Okay? So then we just need to isolate y prime. Okay? Okay ba? So ano ba yung magandang y prime dito? Okay? Okay? So ang gagawin ko dito is yung mga may y prime, ilalagay ko sa right hand side. Yung mga may walang y prime, ilalagay natin sa left hand side. Diba? So therefore, okay? So first, we multiply the whole term by 1/3. Kasi nakita natin lahat sila may naka-multiply na 3. So para mag-cancel na to. Diba? So then, so again sa left hand side muna, so yung may mga walang y prime, So we have this one, so x squared. Okay? So then, ito, walang y prime to. So negative ng y, so minus y. So then yung may mga y prime, so we have this one. So negative to, pag nilipat ko sa right hand side, magiging positive. So kaya we have xy prime. Diba? So tapos ito. So again, positive to, pag nilipat natin sa kabila, magiging negative. So we have minus y squared y prime. Diba? So we can factor out y prime here. So then this will be x minus y squared. So then y prime, so will be given by, so itong quantity na to, so kasi x squared minus y to, so itong quantity na to, so that's x squared minus y, so that's divided by yung naka-multiply kay y prime. So we have x minus y squared. So therefore, so this is our final answer. No? Okay? So x squared minus y, so ito. Okay? Naka ba? So any questions? Diba? So para dito sa solution na to. So again, so this is implicit differentiation. Yung tinatawag. No? Okay? So any questions? Okay. So then, so let's proceed to the next solution. Diba? So again, yung next solution natin is yung tinatawag natin na, or yung ginagamitan natin na tinatawag natin na partial differentiation. No? So ano namang ibig sabihin ng partial differentiation? So what's the difference with ano yung difference niya so sa ordinary differentiation natin. So again, ordinary derivative, we are just getting the derivative with respect to a single variable. Diba? So and, okay, so yung function natin is just a function of a single variable. So ang single variable calculus lang siya. Diba? Okay? So isang variable lang. Okay? So for example, dito yung y as a function of x. Kaya ordinary derivative. No? So pero pagdating sa partial differentiation, sa partial differentiation natin, pwede tayo magkaroon ng two or more independent variable. So pwede ring single variable, pwedeng isa rin lang yung variable. Diba? So pero applicable din siya for two or more variables. And the difference, diba, is pag meron na tayong two or more variables, so we are operating in the three-dimensional space. Diba? And if we are working in a three-dimensional space, there are more than one slope, diba? So of a tangent line, or there are more than one tangent line so for a given curve, diba? So for a given solid, diba? Or for a given figure, diba? So for a three-dimensional space. Okay, so for example, so imagine, let's say we have this three-dimensional figure. So then again, so imagine, so meron kang tangent line dito, so then ito may slope to. So then pwedeng ganito yung direction ng tangent line mo, pwedeng ganito yung direction ng tangent line mo, pwedeng ganito yung direction. So kaya we have different directions na pwedeng i-consider. Diba? And sa partial differentiation, we are getting the slope, diba, so of a tangent line in a specific direction. Diba? Doon lang sa direction kung saan natin siya kinukunan ng derivative. So for example, so if we are getting the partial derivative with respect to x, so then that will be in the x direction. Diba? So in the x-axis direction. Diba? So pag with respect to y, so in the y-axis direction. So therefore, if that's the case, so ibig sabihin, so we are letting the other independent variable constant. So kaya pagdating sa partial derivative, diba? So for example, so we are given so some function u, diba? So which is a function of x and y. Diba? So then pag sinabi natin partial derivative, so which is written by this curve d, so with respect to x, so this is simply the derivative of x, diba? So ordinary derivative. So ng f of xy, diba? So such that we are considering yung y natin to be some constant. Okay? Okay ba? So kaya mag-a-apply yung mga rule natin involving constants. Okay? Okay ba? So pag dating sa partial differentiation. Okay? So pag partial derivative naman, diba? So with respect to y, so then what we do is derivative with respect to y, so ng f of xy, so then this will be so evaluated at x is equal to some constant. Okay, naka ba? So yun yung tatandaan natin sa partial differentiation tinatawag. So now, paano natin to gagamitin, 'di ba? So sa pagkuha ng y prime, 'di ba? So yung tatandaan lang natin dito, remember that y prime is dy over dx, 'di ba? So and note, okay? So if you are given u is equal to f of xy, 'di ba? So if you get the differential of du or the differential of u, so which is du, 'di ba? By definition sa mathematics, okay? So this is defined as the partial derivative of u with respect to x multiplied by dx plus the partial derivative of u, so with respect to y, dy. So again, so gagawin natin to sa lahat ng variables. Since dalawa lang naman yung variable natin dito, diba? So then, dalawa lang yung terms natin dito. Pero for example, may third variable ka pa na z, so meron ka pa ditong partial derivative ni u with respect to z multiplied by dz. And so on and so forth. Diba? So therefore, if this is equal to some constant c, diba? So then this will be equal to the derivative of the constant. Diba? But we know that the derivative of the constant is 0. Diba? So therefore, solving for dy dx here, so y prime is simply dy dx. Diba? So you can imagine so that this will be the negative partial derivative ni u with respect to x divided by partial derivative ni u with respect to y. So therefore, okay, so meron tayong ganitong formula. Okay? Okay ba? So if we are solving for dy dx, diba? So for two variables, okay? Okay ba? So then ito lang yung gagamitin natin equation. Okay? So paano siya magiging applicable? So dito sa problem natin. Okay? Okay, so let's try writing the equation first. So if I let u, diba? So be equal to this function here. Okay, okay ba? So that's equal to x cubed. So minus. So this is 3xy. So then plus y cubed. Diba? So and remember that this is equal to 1. Okay. Okay ba? So then, so if I get the partial derivative ni u with respect to x. So again, so applying this, iti-treat lang natin si y as constant. So therefore, this will be 3x squared. So minus, okay? So y is constant. So kaya pwede natin siyang i-factor out. So kaya magiging minus 3y to. Derivative ng x with respect to x is 1. So kaya wala na matitira dyan. Diba? So then y is constant. Derivative ng constant ay 0. Diba? So therefore, this is simply 3. So times x squared minus y. No? Okay? So again, so yan yung partial ni u with respect to x. So for partial ni u with respect to y, so this time we are treating x constant naman. Diba? So x is constant. Okay? So therefore, so if we get the derivative of this, again, x is constant. So derivative ng constant ay 0. So derivative dito ay 0. So then dito, so negative 3 is constant. So we can factor that out. Diba? So and this time, so x is constant. So therefore, constant din tong x na to. So we can factor that out. Derivative ng y with respect to y is 1. Diba? So then, okay? So then, okay, so we have derivative naman ng y cubed. So that's simply so 3y squared. Okay, so by power rule. So we can factor out 3. So then this will be y squared minus x. No? Okay? So then by applying this formula, diba? So therefore, okay, so therefore, y prime, diba? So will be equal to, so again, negative partial ni u with respect to x. So again, so that's given by this quantity. So we have 3, so times x squared minus y divided by, so partial ni u with respect to y. So that's given by this one. So we have 3, so times y squared minus x. Diba? So then this will cancel. Okay? Okay ba? So then, so this will become, okay, so x squared minus y. So yan kasi yung nasa choices. Tapos yung negative, i-multiply natin sa denominator. So this will be x minus y squared. Diba? So again, so this is our y prime. No? Okay? So this is another way to solve our problem. Okay? Okay ba? So any questions para dito? So again, so yan yung partial differentiation natin. Diba? So tandaan nyo lang tong equation na to. Diba? So para magamit yung partial derivative for the first derivative. Okay? So tinry ko dati mag-derive, diba? So ng format, so for the second derivative, kaso masyadong komplikado using partial derivative. So kaya pag second derivative, so gawin nyo lang is kunin nyo muna yung first derivative, so then get the derivative of the first derivative. So pag mga ganitong form, diba? So kasi meron kayong masasolve na form ng y prime, diba? So either using yung implicit differentiation natin or partial differentiation. So meron kayong masasolve na form ng y prime. So then just get the derivative of that expression, diba? So with respect to x, so then gagamit lang kayo ng chain rule mostly, diba? So chain rule and the other derivative rules na pwede natin i-apply sa problem. Okay? So any questions? Okay. So let's continue. Number 5. Okay, so this time, ano lang to? Product rule lang. Diba? Okay? So then, so we are given two functions. kailangan lang natin kunin yung derivative ng ng product nila, diba? So basically, so we are given, so again, f of x. Okay? So we are given, so f of x, g of x, diba? So this quantity derivative, no? Okay, so then by product rule, so this is f of x, derivative ng g of x, so g prime of x, no? So then plus g of x, so this is derivative ng f of x, so f prime of x, no? So we want to evaluate this at x is equal to 2, so at x is equal to 2, so then we can write this as fg of 2, no? Okay, so this is derivative. So pag fg, ibig sabihin nito naka-multiply sila, diba? So kaya ito equivalent lang dito. No? So yung f of 2 times g of 2, no? Okay, so then this will be f of 2. So g prime of 2, basically lahat ng x papalitan lang natin ng 2. So then we have g of 2, so then f prime of 2, no? Okay, so then from the given, so ano yung f of 2? We have negative 1. Ano yung g prime of 2? That is 2. Ano yung g of 2? G of 2 is negative 3. So then, ano yung f prime of 2? That is 4. So therefore, so this is equal to negative 14. Okay? Nakuha ba? So again, product rule. No? So ito hindi nyo rin ito masosolve using the calculator. Okay? Nakuha ba? Kasi wala kang format ng diniderivative mo. Diba? Wala kang form. Wala kang equation. Diba? Okay? So yan. So, pwede rin natin itong isulat as ganito. So, we have fg prime of 2. So, again, pare-pareho lang yun ang ibig sabihin. So, ito. Okay. So, any questions? Okay. Next, number 6. So, partial differentiation lang to. So, define ko na naman sa inyo yung partial derivative kanina. So, pero this time, makikita natin na yung u natin dito is a function of 3 variables, x, y, and z. Diba? Okay? Okay ba? So again, so this is given by xy plus yz plus zx. Diba? So let's get the partial derivatives. No? First partial derivative. Okay? So kukunin lang natin siya for all variables. So kasi walang sinabi sa atin kung with respect saan yung partial derivative natin. Diba? So let's start with the partial of u. So with respect to x. No? So again, so this is just given by the derivative with respect to x. Diba? Nung function natin. So, function ng x, y, z. But remember that this is only with respect to x. Therefore, yung y and z, iti-treat natin as constant. Okay? So, that's why. So, this will just be given by. So, derivative nito with respect to x. Y is constant. So, we can factor that out. Derivative ng x ay 1. Diba? Plus. So, both of these are constant. So, derivative ng constant ay 0. So, then, derivative nito. So, z is constant. So, we can factor that out. Derivative ng x ay 1. So therefore, this is the first partial derivative with respect to x. Diba? So meron na tayong isa. Okay? Okay ba? So looking at the choices, ang meron lang diyang y plus z is ito. Saka ito. Diba? So therefore, so hindi na pwede maging sagot yung letter A saka yung letter C. Okay? So next, ano naman yung partial derivative ni u with respect sa y? Diba? So again, this time, so derivative naman siya with respect to y. So, nung function natin, so f of x, y, z, such that, since this is with respect to y, so dapat yung x and z natin, so will be treated as constant. Okay? Okay? So, kaya yung magiging equation natin dito will be, so again, so sa term na to, x is constant, so we can factor that out. Derivative ng y with respect to y is 1, plus, so z is constant, so we can factor that out. So derivative ng y with respect to y is 1. So 1 times z is z. Diba? Z and x are both constant, so therefore derivative ng constant with respect to y will be 0. So ito lang yung matitira. So meron na tayong dalawang derivatives. No? Okay? So this is with respect to y. Okay? So dalawa na. So x plus z. So dun sa dalawang choices natin na natitira, ito lang yung may x plus z. So therefore, alam natin na mali ito. So then, alam natin na letter D yung tamang sagot. Diba? So, but let's confirm. So, by solving the partial derivative with respect to z. So, again, so this time, so derivative naman to with respect to z. So, nung function natin, so f of x, y, and z. Diba? So, then this is evaluated. Diba? So, kung saan. Since this is with respect to z, so yung x and y natin so will be treated as constant. No? So this is equal to constant. Okay? Okay? So therefore, okay, so this will be equal to, okay? So we have sa xy, diba? So yung xy natin parehong constant, so therefore derivative niyan ay 0. Sa yz naman, so since y is constant, so we can factor that out. So derivative ng z with respect to z is 1. Diba? Okay? So then, plus. Okay? So sa zx naman, so yung x natin is constant, so we can factor that out. Diba? So tapos derivative ng z with respect to z is 1. So therefore, this is our first partial derivative. So ito yung with respect to z. So makikita natin pareho lang siya dito. Diba? So ibig sabihin tama talaga yung letter D natin. So that's y plus z, x plus z, and y plus x. Okay? So any questions para sa partial derivative? All in all? Okay? So ganyan lang yung partial derivative. So actually, hindi masyado mahirap yung mga tanong sa board exam pagdating sa partial derivatives. No? Okay? So mga ganyan lang kasi yung lumalabas. Diba? So pero minsan, diba? So in some rare cases, meron kasi lumalabas sa board exam na mga maxima minima kung saan you have more than one variable. So you have two variables, for example. So kaya yun yung multivariable maxima minima. Okay? So in which case, kailangan nyo dun yung mga concept ng partial differentiation. Okay? Okay ba? So although sobrang bihira naman sila and usually mga common na tanong lang din. So kaya meron na tayong mga direct formula for those. No? So you can just memorize those. No? Okay. So pero mas okay pa rin pag marunong kayo ng concept ng partial differentiation. Diba? Okay? So any questions? No? So madali lang actually yung partial differentiation. So actually mas madali siya compared sa ordinary derivative in some cases. Kasi sa partial differentiation kasi nagiging constant yung ibang variable. So whereas sa ordinary derivative natin basically gagamit ka doon ng chain rule or gagamit ka ng product rule or quotient rule. So para ma-solve mo lang yung problem. No? Okay? So pero dapat alam niyo syempre yung concept ng partial differentiation. No? And magagamit niyo rin ito pagdating sa vector analysis. No? Kung sino man magtuturo sa inyo ng vector analysis pagdating sa mga parts ng vector field. Okay? Naka ba? Saka scalar fields natin. Okay? So pagdating sa mga directional derivative na tinatawag. Diba? Vector analysis kasi yan. Okay? So any questions? Okay. Okay? So any questions? So for this problem. Okay? Okay? So again, so pagdating sa partial differentiation, so para lang siyang ordinary derivative, no? So kaya applicable pa rin yung sum rule, diba? So kaya dito sum rule lang yung ginawa natin, diba? We get the derivative of each function, so and we just follow yung operation. Okay, naka ba? Kaya puro plus yung lumabas dito. Diba? Okay? Okay, so kasi plus din naman yung nasa given natin, diba? So plus and plus. Okay? So any questions? Other questions, diba? So for this problem. Okay? So then, okay? So this time, so pupunta tayo sa concept ng limits. Okay? Mga ba? So gaya na sabi ko sa inyo kanina, diba? So nung bago tayo mag-start, limits yung isa sa mga pinakamadaling questions. Okay? Mga ba? So na lumalabas pagdating sa differential calculus. Kasi meron tayong calculator. Okay? Mga ba? So yun yung isang tatandaan natin pagdating sa board exam. Okay? So although gaya ng sabi ko sa inyo kanina, try to solve it first by hand. Okay? Naka ba? So huwag tayong aasa kay calculator. No? So kasi minsan, hindi rin kayang i-solve ni calculator sa limits. No? Especially yung mga problem na sobrang tagal mag-converge. Okay? Meron mga ganyang uri ng problem. Okay? Okay? So kasi for example, diba? So imagine nyo, meron tayong graph, diba? Or curve. Okay? So merong isang curve na ganito. Diba? So let's say we are getting the limit as x approaches infinity. So let's say meron kang ganitong curve, diba? And we have this curve. Okay, okay. So we have so we have this curve and this curve, diba? So ito makikita natin mabilis siya mapupunta doon sa value na i-approach niya at infinity. So kasi makikita natin sa part na to halos wala nang change yung graph natin. But as you can see dito, nag-i-increase pa siya, diba? Okay, nakaba. So and possible, diba? So or possibly at some point, at some very far point, so saka lang siya magko-converge sa isang value or never na siya magko-converge. Diba? So in those cases, pag ganito yung problem natin, diba? Tapos lumampas siya dun sa limit ng calculator. Siyempre may memory limit ng calculator. Diba? So then, hindi siya kayang i-solve ng calculator in those cases. No? Okay? And nangyari na yan ata once or twice, diba? Sa board examination. Okay? So kasi yung function na binigay is I think x. Hindi ko lang maalala kung ganito pero parang ganito yung lumabas, no? So 1 over x raised to 1.0001. And I'm not sure kung integral siya or limit. Kasi pag integral tapos merong infinite dun sa limit, no? Dun sa limit of integration. So magli-limits ka rin dun, diba? So parang ganito ata yung lumabas tapos hindi siya ma-solve ni calculator. Okay? Okay ba? So kaya hindi lahat ng limits sa solve ni calculator. So although, 'di ba? So in most cases naman, 'di ba? So kaya siyang i-solve ni calculator. Okay? Especially pag naging yung problem naging naging complex number, no? So nalilito na yung mga estudyante pag complex number yung nasa limits, 'di ba? So pero ganun pa rin naman. Kaya pa rin siyang i-solve ng calculator niya, no? Okay? So pero again, so we will focus on the basic ways, diba, to solve for the limits, okay, so of limits of functions. Okay? Pag sinabi natin limits as the name implies, siya yung ina-approach, diba, so ng function natin at the given point. Diba? Or kung hindi man ina-approach, yung mismong value. Diba? Or yung supposed to be value, diba, so ng function natin so at that specific point. So yun yung tinatawag natin as limits. Okay, makaba? So actually, so this is usually discussed, diba? So kung discuss sa inyo ito ng college, okay? So using graphs, diba? So kasi mas madali natin siya makita using graph, okay? So pero syempre, we will focus on mathematical calculation, diba? So yung number 1 na tatandaan nyo pagdating sa limit is the L'Hopital's rule, okay? So kasi yung L'Hopital's rule, yung pinakamadalas nyo talaga magagamit pagdating sa limits of function. So kaya hindi na natin i-discuss yung ibang mga theorems, diba? So hindi na natin i-discuss yung definition ng limit. So hindi ko alam kung na-encounter nyo yun. So yung may epsilon, diba? So na definition ng limit, no? So ginagawa kasi namin yung dati ng college, pinoprove namin yung mga limit, so gamit yung definition ng limit, no? Okay? So mahilig kasi sa proving yung prof ko dati sa calculus 1 namin, so nung college. Okay? So kaya pinapa-prove sa amin, so using the definition of limits. Okay? So pero again, so we will focus on this lecture sa L'Hopital's rule. Kasi yan yung pinakamadalas yung magagamit sa board exam. And for that, diba? So again, tatandaan natin yung mga tinatawag natin na indeterminate forms. Okay? So ito yung mga indeterminate form, diba? So ng limits natin. So ito yung ibig sabihin ng indeterminate form is pag nag-direct substitution tayo sa limit, kasi limit is basically direct substitution, no? So tapos ang nakuha natin is mga forms na to. So then at that point, that is indeterminate, diba? So ibig sabihin, we need to do something so we can apply theorems, diba? So pagdating sa limits, we can apply L'Hopital's rule, diba? So pagdating sa limits, so para makuha natin kung ano yung ina-approach ng forms na to. Okay? Okay ba? Ano yung mga indeterminate form natin, diba? So the common ones so are 0 over 0, saka infinity over infinity. So yung tatandaan nyo is pag nakuha nyo itong dalawang form na to, pwede natin itong gamitan ng L'Hopital's rule. Okay? Okay ba? So again, so ito, applicable dito yung L'Hopital's rule. So kaya pag napalabas nyo yung 0 over 0 or yung infinity over infinity, so then we can apply the L'Hopital's rule. Okay? Okay ba? So now, diba? So you might argue, diba? So yung iba kasi mga estudyante na nalilito dito. So kasi iniisip nila na 0 over 0 is 1. Diba? So kasi any number divided by another number should always be equal to 1, diba? So by yung tinuturo sa atin ng elementary. Okay? So but again, so that's not applicable for 0 over 0, no? Okay, so it might be applicable, diba? So pag or yung iba naman ang ginagawa 0 over 0 is equal to 0, diba? So again, it might be applicable if we are talking about the real 0, diba? So or the actual 0 or the true 0, diba? Or yung pinaka number natin na 0 divided by another 0, diba? So pero debatable pa siya. Okay? Okay ba? So pero pagdating kasi dito sa limits natin, we are talking about functions. Okay, ba? We are not talking about numbers and we are just approaching 0. So meaning this is not exactly 0, diba? Kumbaga ina-approach lang natin tong 0 na to, diba? So same for infinity, diba? Ina-approach lang natin dito yung infinity, diba? And infinity is not a number, diba? So technically, diba? So infinity is a concept, no? So basically infinity is yung ina-assume natin na ina-approach ng numbers natin so habang lumalaki na lumalaki yung number natin, diba? So therefore in a way or in a sense, diba? So pwede nating iset yung isang malaking number as infinity. For example, 1 million can be considered as an infinity, diba? So with respect to some very small number, diba? So or 10 million can be considered as infinity. 100 million can be considered as infinity, and so on and so forth, diba? So kaya maraming ibig sabihin tong infinity. This is an abstract concept, diba? So actually lately may napanood ako dun sa Facebook na video, diba? So yung concept ng countable infinity and uncountable infinity, diba? So again, so infinity is not a definite number, no? Wala siyang exact value, diba? So pero alam natin na this is a very large number. So but it can be different, diba? So kaya infinity over infinity can be different number. It can be equal to 1, it can be equal to 2, it can be equal to 3, it can be equal to infinity, it can be equal to 500, and so on and so forth, no? So kaya indeterminate pa yung form nila. Diba? So kaya ang gagawin natin, maglo-L'Hopital's rule tayo. So if we encounter these indeterminate forms. So what are the other indeterminate forms? Diba? So we also have 0 times infinity. Diba? Okay? So yung concept naman dito kaya siya indeterminate is any number multiplied by 0 is 0 and any number multiplied by infinity is infinity. So therefore, diba? So merong isang part, diba, na nagpapa-increase sa kanya sa infinity, merong isang part na nagpapa-decrease sa kanya sa 0. Diba? So therefore, this value is somewhere in between. Diba? Okay? So somewhere in between 0 and infinity. Okay? So kaya indeterminate yung form natin dyan. Okay? So ano pa yung mga indeterminate forms natin? So we also have 1 raised to infinity. Okay? So ito medyo hindi rin nagme-make sense, diba, kung isipin. Kasi kung 1 raised to infinity, kahit ilang beses mo i-multiply yung 1 sa sarili niya, dapat 1 yung lalabas, diba? So pero sa mathematics, so this is an indeterminate form. Okay? So kaya pag napalabas yung 1 raised to infinity, diba? So then indeterminate siya. Okay, ba? So and yung mahirap kasi sa mga ganitong uri ng problem, so is hindi applicable dito yung L'Hopital's rule. So pag ganito yung napalabas nyo, ganito yung napalabas nyo, so hindi pa dyan applicable yung L'Hopital's rule. So kailangan nyo munang i-simplify to papunta sa form na to, so para magamit yung L'Hopital's rule, di ba? For example, so ito, okay? So then, so para makuha natin yung L'Hopital's rule dito, so pwede natin itong gawing 0 divided by the reciprocal of infinity, di ba? Kasi alam natin the reciprocal of infinity is 0. So therefore, saka pa magiging 0 over 0, saka pa natin ma-apply si L'Hopital's rule. Okay? Okay ba? So para naman dito, so gagamit pa tayo ng ln, di ba? So if we use ln of 1 raised to infinity by using concept ng logarithm, so this will be infinity times ln1. ln1 is 0, so we get infinity times 0. So then we apply this, diba? So then pwede natin itong gawing 0 over 0, saka pa natin magagamit si L'Hopital's rule, diba? And after natin gamitin si L'Hopital's rule, i-erase pa natin siya from e, diba? Kasi ginawa natin to. So kaya basically yung magiging result ng e raised to 0 over 0, diba? Okay? So kaya kahit ano mapalabas nating indeterminate form, actually, pwede natin siyang gamitan ng L'Hopital's rule. Okay? Okay ba? So yan. Okay? So I think same pagdating kay infinity raised to 0. Infinity raised to 0. So again, so this is also indeterminate. Okay? Okay ba? So we also have yung infinity minus infinity. So infinity minus infinity is different type. No? So hindi natin ito pwede magamitan ng L'Hopital's rule. Okay? Okay ba? So, yan. So, pagdating sa infinity minus infinity, usually, sinisimplify lang natin to using algebra. So, then, saka natin siya ina-applyan ng limits. Okay, nakuha ba? Basically, hahanapin lang natin dito yung factor, diba? So, na nagpapa-infinity dun sa dalawang number natin. Okay, so tapos kailangan lang natin siyang gawa ng paraan. Okay? So, yan. So, yan actually yung mga ilan sa mga indeterminate forms natin. So, marami pa tayong indeterminate forms, pero ito yung madalas yung makikita pagdating sa board exam. Okay? Nakuha ba? So, kaya yung mga tatandaan natin indeterminate forms. No? Baka kasi pag nakita nyo to, for example, nakakita kayo ng ganito, gawin yung 0. So, again, this is not always 0. No? So, again, so kaya dapat alam nyo at least itong mga forms na to. So, again, so para mas madali nyo ma-solve yung mga problems. Okay? So, let's try. Diba? So, some examples sa limits. Okay? So, let's try this one. Okay? So, the limit, okay, so of x squared minus 4. So, this is divided by, so we have x minus 2. So, as x approaches 2. Okay? So, again, so yan yung given sa atin. Diba? So, for this problem. Okay? So, let's try to solve this first. So, using basic algebra. Okay? Nakuha ba? So, again, so pag nag-direct substitution tayo dito, diba? So, you will get 2 squared minus 4. So, we have 2 squared minus 4. So, then this is divided by 2 minus 2. Diba? So, makikita natin that this will just be equal to 0 over 0. So, again, so this is indeterminate. Okay? Nakuha ba? So, ibig sabihin, diba? So, meron pa tayong kailangan gawin para ma-solve natin to. Diba? So, let's try our first solution. So, again, first solution is by algebraic manipulation. Diba? So, basically, kung matatanggal natin yung factor na nagbibigay sa atin ng 0 over 0 sa fractions natin, so then we can factor that out. Diba? So, para mag-cancel yung nagpapa-0 sa atin. Diba? Kasi baka mamaya pareho lang pala yung nagpapa-0. Diba? So, therefore, we can cancel that. Okay? So, then ang gagawin natin, so we will factor, diba? So, yung numerator saka yung denominator natin. So, for the numerator, this is the difference of 2 squares. So, kaya yung factor natin dyan will be the sum and difference of square root ng dalawang term natin. Square root ng x squared is x, square root ng 4 is 2. So, then this is divided by x minus 2. Diba? Kaya makikita natin ito yung nagpapa-0. Diba? Dun sa fraction natin. So, then we can cancel that. Okay? So therefore, so you will get that the limit, diba, so of this function as x approaches 2 will be 2 plus 2. So this is equal to 4. Okay? So kaya ito yung lalabas na sagot natin dyan. No? Okay? So again, that's our first solution. So algebraic manipulation. Pero alam naman natin na hindi laging applicable yung algebraic manipulation natin. Diba? Okay? So kasi there are times, diba, na hindi naman pareho yung magpapa-0 dun sa numerator sa denominator, so we cannot cancel. Diba? So in those cases, syempre, we also have different solutions, pero again, so we, ang preferred na natin for those cases is L'Hopital's rule. Diba? So kasi mas madaling gamitin yung L'Hopital's rule, especially kung marunong kayo mag-derivative. Diba? Okay? Solution to natin is by using L'Hopital's rule. Kasi remember, pag ganito yung form natin, pwede natin itong gamitan ng L'Hopital's rule. Diba? Basta 0 over 0 or infinity over infinity mapalabas natin. Okay? Ano ba yung sinasabi ng L'Hopital's rule? Diba? So yung sinasabi ng L'Hopital's rule, so is that, okay, so if the limit, okay, so as x approaches some value a, diba? So ng f of x, diba? So over g of x, diba? So we have a fraction. So again, if yung limit nito, so if the limit, okay, is equal to, diba? So 0 over 0 or infinity over infinity, diba? So then, we can apply L'Hopital's rule such that, ang gagawin lang natin, i-derivative lang natin si numerator, tapos i-derivative lang natin si denominator. No? So again, so these two will be equal. Okay? So again, so itong values nito, so will just be equal. Okay? Okay ba? So yun yung tinatawag natin L'Hopital's rule. Okay? Okay ba? Kaya pag napalabas natin to, so yung infinity over infinity or yung 0 over 0, so then, diba? So pwedeng i-derivative na lang natin yung numerator, i-derivative natin yung denominator, so then we repeat. Diba? Pag 0 over 0 or infinity over infinity pa rin yung lumabas, so ulitin lang natin. Diba? So until mapalabas natin yung tamang sagot. Diba? So again, remember, this is only applicable pag napalabas natin yung 0 over 0 or infinity over infinity. So meron kasi yung kinalaman doon sa slope. Diba? So, nung lines natin, or nung curves natin. So, kaya applicable sila L'Hopital's rule. Okay, so as solution 2, so by L'Hopital's rule, diba? So we have the limit as x approaches 2. So ng x squared minus 4 divided by x minus 2 is simply equal to, so the limit as x approaches 2, diba? So ng derivative ng numerator, 2x, diba? Kasi derivative ng negative 4 is 0, diba? So this is 2x. Divided by, so derivative naman ng x is 1. So this will be 1, diba? So therefore, so by direct substitution, this will be 2 times 2 divided by 1, so you will get 4. So we have the same answer, diba? So yan naman yung tinatawag natin L'Hopital's rule, diba? Okay? So any questions para dito? Okay? So next, diba? So yung next solution natin syempre is by using, okay, so yung calculator natin. No? So pag gagamit kayo ng calculator, so all you have to do is to replace, diba? So yung 2 natin, yung ina-approach ng x natin by another number na sobrang lapit sa 2. Diba? So for example, diba? So let's say, diba? So again, since x is equal to 2, so ang gamitin nating value ng x for example is 1.9. Okay? Naka ba? So tawagin ko muna tong limit na to. So tawagin natin tong limit na to as L. So then tignan natin kung ano yung magiging value ni L. Diba? So gawa ko ng table. Diba? So let's try so several values of x. Okay? So tapos tignan natin kung ano yung magiging limit. Okay? Nakaba kung ano yung lalabas na L. So again, so let's try. So 1.9, then 1.99, so then 1.999. So I think that's enough, no? Okay? So then, so again, so ito yung function natin. So let's input that. So we have x squared or fraction. So we have x squared minus 4. So then divided by, so we have x minus 2. So let's try to calculate this. Diba? So again, at 1.9. Okay, so syempre, pag 2 yung ginamit natin, so this will be error. So kasi wala tayong value for 0 over 0 sa calculator. No? So kaya let's try 1.9. Diba? So in this case, okay. So we have 3.9. So yung lalabas. Okay, so this is 3.9. Okay. So let's try 1.99. So we get 3.99. Diba? Okay. So then we try, so 1.999. So we get 3.999 yung lalabas. Diba? So and as you can see, diba? So habang lumalapit siya sa 2, diba? So then palapit ng palapit sa 4. So yung limit natin. So therefore, as this approaches 2, so we know that this will approach 4. Diba? So tingnan natin, diba? Kung kailan siya makikita ng calculator as 4. So if we further increase this, diba? So let's say ito. Itong 9, diba? So we get 4 na approximately. Diba? Kasi lumampas na siya dun sa rounding ng calculator. No? Okay? So try muna natin sa 4 na 9. So 3.9999. Diba? Sa 5 9. So we get 3.99999. So again, palapit siya ng palapit kay 4. Diba? Pag 6, so 6 na 9. Pag 7, so yan. So 4 na yung lumalabas kay calculator. Diba? So ibig sabihin, so habang papalapit siya kay 2, so papalapit talaga to kay 4. So if we further increase this, or para mas malapit pa kay 2, diba? So makikita natin na, okay, so error. So hindi na kaya ng calculator. Okay, so yan. So 4 pa rin yung lumalabas, no? Okay? So again, so kahit na, i-increase pa natin or mas palapitin pa natin to kay 2. Okay? Nakuha ba? So again, so yun yung ano natin. Okay? So may question ba? Sige. Anong question mo? Anong question natin? Okay? Okay? So,
Sir Raymond, si Mr. Carodan ata, merong tanong. Naka-raise kasi siya ng hand.
oo, tinatanong ko rin siya. So, i-message mo na lang sa akin yung question mo kung hindi ka makapagsalita. No? Okay? So, again, so message mo na lang sa akin yung question mo. So, kung hindi ka makapagsalita. No? Okay? So, again, so another way dito, diba? So, instead of 1.9, okay? So, pwede natin gawin is, pwede namang mas mataas sa 2 yung gamitin natin. So, for example, so we can use 2.01, diba? Or 2.001, okay? Okay ba? So, we can also do that. Okay. Hindi natin siyang bawasan, diba? So, 001, diba? And so on. Tapos tignan natin kung ano yung ina-approach niya, diba? So again, so as we make it closer to 2, okay? Okay ba? So again, so if we do that, so ganun pa rin, diba? So we just use yung, we will just use this function here. So then calculate natin. So at 2.1, so then we will get 4.1, diba? Okay? So 4.1. Okay, so then, so try natin sa 2.01. So we get 4.01. So this is 4.01. So then we get at 2.001. So we get 4.001. Diba? So then we get 2.0001. Diba? So then this is 4.0001. Okay? So then pag 2.00001, so then we get this one. 4.00001, diba? So ay makikita natin again, papalapit siya ng papalapit kay 4. Diba? So paliit din ng paliit yung value ng L natin, diba? So papunta kay 4. So again, so as we make yung X natin closer sa 2, diba? Okay? So again, so I think so ganun din. So 7 zeros. Ayan. So bago makita siya ni calculator as 4, no? Okay? So again, sabihin at that value, diba? So of X, okay? So na-round off na siya ni calculator as 4, diba? Okay, so kaya alam natin pag niliitan pa natin itong naliitan, so then 4 na lang yung magiging value sa calculator, diba? So until again hindi na uli kayanin ng memory niya, so then mag-error na uli si calculator at that time. So are there questions? Okay, so regarding this topic? Okay. May tanong ba? Okay. So again, kung may tanong ka, Mr. Ano ba to, Karodan? Again, so message mo na lang sa akin sa dito. No? So balikan na lang natin later. Okay? Kung ano yung question mo. No? Okay? So again, so message mo na lang dito. No? So dito sa Zoom. So may Zoom chat naman tayo. Okay? So check mo lang doon sa options. Okay? So kung ang gamit mo is laptop. No? Okay? So nasa ano din to, sa pag phone naman yung gamit nyo, so nandun din sa options. Okay? So move na ako dun sa next problem. Okay? So this time, so let's discuss this one. Diba? So evaluate the limits of x sine pi over x as x approaches infinity. No? So try natin to. Okay? So again, so we want to get the limit. Okay? So of x sine of pi over x. So this is as x approaches infinity. Okay? So again, so yan yung given sa atin. So again, so if we use direct substitution dito, so then this will just be equal to infinity multiplied by sine of pi over infinity. Diba? So again, if you have a number, diba? So which is divided by a very large number, so then that will approach 0. Diba? So kasi habang palaki ng palaki yung dinidivide natin, paliit ng paliit yung portion. Diba? So na mapupunta dun sa quotient natin. Diba? Paliit ng paliit yung quotient natin. Okay? So kaya alam natin na pi over infinity will approach 0 and sine 0 is 0. So therefore, so this will approach infinity multiplied by 0. Diba? And again, so we know that this is indeterminate. Okay? But again, so in this form, so hindi pa applicable si L'Hopital's rule. Diba? And as you can see here, diba? So yung nagpapa-infinity, diba? So dito sa part na to, so kaya nagpapa-0 sa part na to, which is this one, so cannot be cancelled. Diba? So kasi meron kang sign. Diba? So hindi naman natin pwede i-cancel directly yung dalawang x dito. Diba? So kaya again, so not all the time, so gumagana yung factoring na solution. Diba? So dun sa problems natin. Okay? So again, so this is one example. Diba? So now let's try to solve this. Okay? So using L'Hopital's rule. Diba? So pero again, para makuha natin yung L'Hopital's rule, kailangan muna natin ito gawing 0 over 0 or infinity over infinity. So gaya ng sinabi ko sa inyo kanina, pag ganito yung format natin, so ang ibig sabihin lang niyan is, kailangan nating ilagay yung isang part.
Recording
diba? So,
stopped.
okay. Na off ba yung record?
Recording in progress.
Okay. Okay. So then, diba? So, tuloy natin. So again, so pag ganito yung nakuha natin ng formats, ang kailangan lang natin gawin is ilipat yung isang factor sa denominator. Diba? So pwedeng infinity yung ilagay natin sa denominator. So to make a 0 over 0, or yung 0 ilagay natin sa denominator to make an infinity over infinity. Diba? So pero again, so depende yan din sa problem. Diba? So pag-isipan nyo muna, diba? So kung ano yung ilalagay nyo sa denominator, so para mas mapadali yung pag-solve nyo sa problem. Okay? Okay ba? So kasi for example, dito sa problem natin, ito yung nagbibigay sa atin ng infinity. So itong factor na to. Ito yung factor naman nagbibigay sa atin ng 0. Diba? So therefore, isa dyan, ilalagay natin sa denominator. But you can imagine na pag ito yung nilagay natin sa denominator, yung sign, yung ilagay natin sa denominator, diba? So then that
Recording
sign,
stopped.
okay? Nag-disconnect si sir.
Recording in progress.
Okay? Okay? So again, so balik tayo dito. So again, so yung x, diba? So yung nagpapa-infinity dun sa dun sa function natin. So then sin pi over x naman yung nagpapa-0. So ibig sabihin isa dyan, kailangan natin ilagay sa denominator. Diba? So again, to form an infinity over 0 over 0. But, diba? So if yung sin yung nilagay natin sa denominator, so then that will be the okay, sa akin, so that will be the reciprocal of sine, diba? So, ibig sabihin, pwede natin siyang gawing cosecant, diba? So, then, kukunin natin yung derivative ng cosecant, diba? So, ano ba yung derivative ng cosecant? That's negative cotangent cosecant, diba? Okay? So, again, so if may question kayo, message muna kayo, no? Or raise kayo ng hand, no? Okay? So, yan. So again, diba? So that will be negative cotangent cosecant. That's the derivative of cosecant. Diba? So then, multiplied by the derivative of pi over x. So kaya makikita natin sa masahaba yung equation natin. So as opposed, pag yung x yung nilagay natin sa denominator, so that will just be the derivative of 1 over x. Diba? So which is much simpler compared sa derivative ng cosecant. Okay? Okay ba? So on the other hand, yung derivative naman ng sine, diba? So it's just cosine. So one term lang compared sa derivative ng cosecant. So na negative cotangent sa cosecant. Diba? So therefore, so by taking that into consideration, it's better to put x sa denominator rather than sine. Diba? So kaya ganun yung gagawin natin dito. Diba? So this will just be equal to the limit. Diba? So as x approaches infinity. So again, ano lang to? Algebraic manipulation. Okay, so kaya wala pa tayong ginagawang L'Hopital's rule. So again, so if we do this, diba? So by using direct substitution, so this will be sine so of pi over infinity. So then this is divided by 1 over infinity. So again, so as I explained earlier, pi over infinity approaches 0. So kaya sine of pi over infinity approaches 0 as well. So and 1 over infinity approaches 0. So kaya magigitong 0 over 0. So ibig sabihin, this is still indeterminate. So pero pwede na natin itong gamitan ng L'Hopital's rule. Diba? So by applying L'Hopital's rule, so this will be the limit as x approaches infinity. Derivative ng sine pi over x is cosine. Diba? So pi over x, diba? Derivative ng sine is cosine. But remember na meron kang function sa loob ng sine. That's pi over x. Diba? So tapos, okay? So kukunin lang natin yung derivative niyan. So since pi is constant, so we can factor that out. So that's pi. So then multiply this by the derivative with respect to x, diba? So ng 1 over x, diba? So kahit hindi natin alam yung derivative na yan, so okay lang. So kasi, okay, so pag kinuha natin yung nasa denominator, so yung derivative na to, so this will just cancel, diba? So pero ilagay ko rin as note, diba? So if you want to get the derivative with respect to x, ng 1 over x, so saan to equal, diba? So this is the derivative with respect to x ng x to the negative 1. Diba? So sa denominator yung x, so therefore by using power rule, this will be negative x raised to negative 2 or negative 1 over x squared. Diba? So pag ginawa natin siya dito, magka-cancel din lang siya. So kaya hindi ko na sinolve yung derivative ng 1 over x. So then, direct substitution na lang to. This will be pi cosine of pi over infinity. So again, pi over infinity approaches 0. So therefore, this will approach cosine 0. Cosine 0 is 1. So this will approach pi. Okay, nakuha ba? So kaya yan yung lalabas sa sagot sa atin. So we have letter C, pi. Okay? Okay? So, any questions para dito? Okay. So, again, so tignan natin sa calculator. So, kung yan talaga yung i-approach natin. So, as we increase the value of x, no? So, again, x. So, then let's call this as our limit. Okay? So, let's call this as our limit. No? So, again, so that's L. Okay? So, then, okay, so again, start tayo sa large number, diba? So, let me try 999 first. Tapos, unti-unti natin siyang i-increase, no? So, again, so until malaman natin kung ano yung i-approach niya as x approaches infinity. Diba? So, again, so if we do that, okay, so this will be, so we have x, no? So, again, so make sure naka-regions mode kayo. So, naka-regions naman to. So, again, so para hindi na natin kailangan ito i-convert sa degree. Kasi ito naka-regions to, most likely. Diba? So, kaya yan yung gagamitin natin. So, we have pi. So, then divided by, okay, so again, so x sine, so then pi, divided by, so x, okay. So again, so then, naka-regions naman to, so walang problem doon. So, let's calculate this, okay. So again, so at infinity, so again, so mag-try muna ako sa 999. So, if we try this, diba? So, we have 3.141587. So, 3.14159. Okay? So, yan yung L natin. Diba? So, if we try 9,999, so we have 3.14159. No? Okay? Or, ito muna yung sulat natin. So, 87476. No? This is 87, so 476. Okay? So, tapos, after nyan, so we have 1592602. Diba? So, saan ba equal yung pi? Diba? So, the exact value of pi is, or, okay, so yung medyo exact value niya dito is 3.141592654. So, this is 2654. No? Okay? So, kaya makikita natin dito, palapit siya ng palapit kay pi. Diba? So, if we try, okay? So, if we try 99999, diba? So, we have 3.14159. So, this is 3.14159. So, 2653. Diba? So, makikita natin sobrang lapit na niya sa kay pi. Diba? So, kaya alam natin na pag in-increase pa natin to, so then this will approach pi. Okay? Okay ba? So, again, so yun yung sagot natin. Diba? So, para dito sa problem na to. Okay? Kaya pwede nyo rin gamitan ng calculator. Diba? Okay? So, pwedeng gumamit kagad kayo ng sobrang laking number. Diba? So, for example, gamit tayo ng sobrang laking number. Diba? So, then, makikita nyo na magsisimplify na siya sa pi. Diba? So, kasi nakikita na siya nung calculator na nag-i-equate na siya. Diba? Pag ni-round off, so dun sa value ng pi na nakastore kay calculator. Diba? So, kaya magsisimplify na siya dun sa value. Diba? So, kung saan siya saan siya nag-approach. Okay? Okay ba? So again, so if we further increase this, so ilan na ba ito? Siyam? So 10. Okay? So then pi pa rin yung lalabas. So ibig sabihin kahit anong increase natin dyan, pi yung ina-approach ng function natin. Okay? Okay ba? So yan yung sagot natin sa problem na ito. Okay? Okay? So then, so next problem tayo. So limits pa rin. Okay? So pero dito ibang format na naman ito ng indeterminate form. Okay? So this time, so we get the limit. So as x approaches 1. So ng 2 minus x. So this is raised to the power of tangent of. So this is pi x over 2. No? Okay? Okay ba? So then, so pag nag-direct substitution tayo dito, so then you will get this is 2 minus 1. So then raised to tangent of pi times 1 over 2. Diba? So then this is equivalent to, so 2 minus 1 is 1. Then ano yung tangent of pi over 2? So remember that tangent, diba? Okay, so note. So tangent of x is equal to sine x over cosine x, diba? So trigonometric identity. So at pi over 2, diba? So yung tangent of pi over 2 So is equal to sine of pi over 2 divided by cosine of pi over 2. So alam natin sine of pi over 2 is 1. Cosine of pi over 2 is 0. So therefore 1 over 0 is infinity. Diba? So kaya alam natin this is 1 raised to infinity. Diba? And gaya na sinabi ko kanina, this is an indeterminate form. Diba? So pero hindi applicable sa kanya si L'Hopital's rule. Diba? So kaya okay, so hindi applicable sa kanya yung L'Hopital's rule. So kaya gagawa pa tayo ng paraan para ma-solve ito. Diba? And gaya na sinabi ko sa inyo kanina, diba? So gagamit tayo dito ng logarithm. Diba? So para mapalabas natin si 0 over 0. So let y, diba? So be equal to, okay, so we have yung nasa loob ng limit. So this is tangent of pi over 2x. No? So then if I get ln of y, so then this will be ln of 2 minus x. So raised to tangent of pi over 2. So then multiplied by x. Diba? So therefore, so by using property of logarithm, so pwede nating ibaba yung tangent na nakamultiply sa ln. Diba? So pi over 2x multiplied by ln of 2 minus x. Diba? So again, so ito yung ln of y natin. Okay? So tapos, okay? So we will get the limit. Diba? So instead of getting the limit ng y, so itong sinosolve natin, so ang gagamitin natin dito is yung limit ng ln of y. Diba? So again, as x approaches 1. So if we use direct substitution here, this will be tangent ng pi over 2, so times 1. This is multiplied by, so we have ln ng 2 minus 1. Diba? And again, so tangent ng pi over 2 is infinity. Tapos yung ln ng 1 naman ay 0. Diba? Okay? So yan yung lalabas sa atin. Diba? And again, pag ganito yung lumabas, this is still an indeterminate form. Diba? So pero, hindi pa rin applicable si L'Hopital's rule. Pero again, pwede nating ilagay yung isang factor sa denominator. Diba? And once again, so yung mas madaling ilagay dito ng factor sa denominator is yung tangent in this case. Kasi yung tangent, pag nilagay natin sa denominator, magiging lang siyang cotangent. Diba? So kaya wala tayong magiging problema in that case. Diba? Or mas madali siyang kunan ng derivative rather than the reciprocal of the logarithm. Diba? So kaya mangyayari dito, so this will be, okay? So this will just be equal to the limit, no? As x approaches 1, so nang, okay, so yung ln of 2 minus x, so iwan ko lang sa numerator. Then yung tangent, pag nilagay natin sa denominator, magre-reciprocal yan. Ang reciprocal ng tangent ay cotangent. So this will be cotangent of pi over 2 multiplied by x. Diba? So then, so by direct substitution, in this case, this will be ln of 2 minus 1 divided by, so cotangent of pi over 2, so times 1. No? Okay, so ln of 1 is 0. So how about cotangent? Cotangent, kabaliktaran nito, cosine over sine. So that will be 0 over 1 or 0. So 0 over 0, indeterminate, pero pwede na natin gamitan ng L'Hopital's rule. Diba? So let's try. Okay, so using L'Hopital's rule here. So again, so by using L'Hopital's rule, so kailangan lang natin kunin yung derivative ng nasa numerator. So that is, derivative ng ln is 1 over x. Diba? Kaya 1 over, kung ano man yung nasa loob ng ln, tapos multiplied by the derivative ng nasa loob. Derivative ng nasa loob, negative 1. So this is divided by, so derivative ng cotangent, that is negative cosecant squared. So then pi over 2, so x, diba? So multiplied by, so derivative nung nasa loob, that's pi over 2. Diba? Okay? So therefore, so we can cancel the negative 1. Diba? So by direct substitution, so this will be 1 over 2 minus 1. So this is multiplied by, okay, or divided by. So we have cosecant squared. So of pi over 2 times 1. So remember, cosecant is 1 over sine. Diba? So then this is multiplied by pi over 2. So again, so 1 over sine to. So ang sine ng pi over 2 ay 1. So kaya reciprocal ng 1 still 1. 1 squared is 1. So kaya 1 over 1 over pi over 2 lang to. Diba? So kaya lalabas dito is 2 over pi. Okay? So again, so yan yung lalabas na limit, diba? So pero limit pa lang to ni ln y. Diba? So ibig sabihin, so meron pa tayo kailangan gawin dito, diba? Okay, so again, so remember, so as, okay, so in this case, so as x approaches 1, diba? So yung lny approaches 2 over pi. So therefore, pag ni-raise natin to ng e, so then you will get that y approaches e raised to 2 over pi. So ito yung sagot natin. Diba? So we have letter A. Okay? Okay ba? So again, kayo na lang mag-try sa calculator. So just choose a number so very close to 1. So tapos i-try nyo. So then, evaluate nyo to para makuha nyo yung decimal value nito. Tapos try nyo siyang i-compare. Diba? So makikita nyo na habang lumalapit kayo kay 1, so palapit kayo ng palapit sa value na e raised to 2 over 5. No? Okay? So any questions para dito? Okay? So kaya again, so kahit ano makuha nyo indeterminate form, meron yung specific na step, diba? So na kailangan yung gawin para ma-solve yung problem. So practicein nyo lang, diba? So para masanay kayo, diba? So yung infinity raised to 0, ganito din lang yung solution. Gagamit kayo ng logarithm, diba? Kasi yung infinity raised to 0, pag ginamitan nyo ng logarithm, so will be 0 times ln of infinity. So ln of infinity is infinity, kaya magiging siyang 0 times infinity. No? Okay? So any questions so far? Okay, okay ba? So wala kayong questions, so let's have a short break, no? So mga 15 minutes break, okay? So let's continue by 10:35, okay? Okay ba? So para makapahinga din kayo, no? So kasi medyo mabibigat talaga yung mga lectures natin ngayon, okay? Okay ba? So mabibigat yung subjects natin, diba? So calculus.
Sir Raymond,
Yes, sir.
nakalimutan kong sabihin na may kayo sa 15 minutes. So, mag-break kayo for the please come back at 10:35. Especially kay kailangan niyang mag-break din.
Okay, so again, so let's continue by
1.5 hour na
10:35.
siyang nagsasabi.
Sige, sir.
And then Sir Raymond, may break, ang break is 12 to 1. Ang noon break ninyo is 12 to 1.
Okay, sir. 12 to 1 yung lunch break.